You do. Just making sure things are working. It's been a while since I've done a live stream. It's been a couple of months, something like that. Right. Okay. That's working. Brilliant. So, how's it going, Paul? Wilhelm? Okay. Still trying to wake up a bit early in the morning. And I look at this thinking, I need a haircut again. Anyway. Yeah. Hey, Peter. Okay. We have a few things to play with today. Well, a few things potentially to play with today. We've got a few projects we could fix. A few live repairs. One thing I've been asked to look at, which I'll be doing first. Hey, Derek. From Newcastle upon Tyne, eh? Yeah, so we've got a few things I'm going to work on, and I will have to do a poll, I suppose, like usual, and see what we end up playing around with. One of the things is quite large. We're seeing it in a mailbag video recently. Capacitance standard. One of the things I want to do with that is actually pull it apart and measure up the side panel, because I have an idea that I could maybe model it up and get a new side panel made, because it's got the broken handle. I don't know if you saw it or not on the mailbag, but one of the handles are broken off it and the other one's slightly bent. So if I'm thinking, if I can strip it down and model up the side panels, I might be able to get new panels made, get them CNC'd, and just replace them. I don't know if I'll do that or not, but yeah, so I've got a nice little simple repair there. Got like a garage door opener thing which you want to repair. Hey, Peter from Belfast. So that's been given to me yesterday to look at. That may be easy. We could probably chuck on things like the spectrum analyzer and have a look at the output, make sure it's actually outputting a signal and that sort of stuff. We do that. I've got the tools for it, so I might as well do it. And so it's another pile of things. I've got literally a pile of things behind me of things to actually do projects on or work on. Thomas from Prague. Present rest of the year. Well, today is the last day of the year for me. Today is the 31st, because I'm from the future. Hey, Ian. I often get comments from my mailbag videos because I publish them at like quarter to midnight or something like that on a Sunday night. And hey, Dave and Christian. So I get comments about them being on a Sunday when actually not on a Monday, you know. But well, it kind of is a Monday because it is for me. Yeah, I need coffee, alright. I've got the Danger Mouse mug for the coffee. I'm getting there. Here for a bit. I'll go again soon. Okay, Chris, no worries. 7 PM Saturday. Yep. Yeah, this time zone thing works out quite nicely for me. I mean, for me it's 8 o'clock in the morning on Sunday, so I'm like 12 hours, 13 hours ahead right now. So I know it works in my favour right now with a 13-hour shift because I'm not clashing with Big Clive. Well, not yet anyway. I will be later on. But this is just the time that suits me best to do streams. So 11 AM there, is it? Okay. Yeah. So, like I said, I've got a few projects to work on, and I'll do a poll. And so things I've got. So it's a garage drive now, which we're definitely doing today. There's a portable DVD player, which I've been meaning to get to for a while. I'd like to get rid of that. Then we've got a Keysight 260 nanovolt meter. I think it's nanovolt meter, something like that. Nanovolt? Yeah, nanovolt source. And then we've got some other stuff too. Then obviously got the capacitance standard, big thing. Pascal. Belgium. Times are weird. Yeah. Everyone should just have the same time. It'd be easy. Looking a DeLorean shirt. Look. Yeah, sure. Not bad. Wife got it for me for Christmas. One of the things she got me for Christmas. She got me a few things. Yeah. Okay, so hopefully everyone's been having a good Christmas and a bit of a break and what have you. Ian, how did your battery bank thing go? I know you were still tinkering with some stuff on that, weren't you? Last thing I saw. Summer, yeah, summer here. I was toying up between this and a singlet because it's hot, but I've got the air conditioning on, so hopefully I don't, get too hot. We'll see how we go. But minutes away from where you are. Cool. Yeah, it's amazing how they've become like a real collector's car, like so unique. I'd love to have one myself, personally. Love to have one. Old technology and stuff like that, but they just look amazing to me. I don't know, I think they're brilliant. But yeah, things don't last so long though. What was it, 40 years old? Half price tariffs and 2 to 5. Only give you 3 hours. Only 3 hours. Haven't you got solar, Alan? Alan, fucking hell. Ian, haven't you got solar? I had some solar power as well. Audio's a bit low, maybe. Well, last time I complained about it as a bit being a bit high, so I backed it down a bit. Let's wind up a bit. There we go. I'll give you some more audio. Be a bit happy with that. The mic is facing diagonally over there, so it's more towards the other desk. That probably isn't helping. It's not solar as well. Okay. Right. Yeah, I like the idea of having solar, but I'm not going to be staying in this place forever, so I don't really want to commit to building a system and then not long enough to have the system running or whatever. Be walking away from it. I'd rather wait. If I would have liked to done it like 10 years ago, really, but yeah. Solar would be awesome. Yeah. Whether it would be battery connected or not, I don't know. It would just be like a microinverter sort of setup where it's just straight on, supplementing the grid supply. I don't know, but I'd like to do it one day. Yeah, I've watched some YouTube channels about issues with the engines, and there's like a design flaw where in between the cylinders and the V in the cylinders, they tend to get corrosion and rust right through the casing because the water gets trapped in there. I'm going to move in a couple of years. Consider after that. Yeah, I've been doing the same sort of thing. I mean, my wife's keen to move from here, and to be honest, we do kind of need more space. I've got too much test gear now. I need a bigger room. I've got 2 rooms for my test gear and I ain't got enough space. Yeah. So that's something we will be doing eventually, is moving. One day. It's on the cards. The only thing is, right now my garage is, its roof line is perfectly aligned to face north, right? It's got a north facing side on the garage. In the southern hemisphere, you have to face north to get the sun, in case you don't realise that. So, northern hemisphere, you have to face south. So, it's like perfect for sitting solar panels up on it. Stick them straight on the roof, no special bracketry, just the plain frame on the roof, done. It'd be just about perfect for it. So, it's a shame, really. Industrial electronics, okay. Well, when it comes to repair stuff, charge. I mean, I'm not really into. I don't really do it for making money. When any stuff I repair, I do it usually to help people out. So I'm not doing it for money. Anything I do for third parties, all right. So I'm just trying to see what my notification's about here. So me trying to give advice about what to charge, not a good idea. There's other people which may have a better idea because they are doing it for business, and they are doing it to earn an income, which is a very different, kettle of fish sort of thing. So I'd say generally charge what you feel comfortable charging. Don't undervalue your time. That's one of the first things I'd say. Hey Andrew, how's it going? People undervalue their time. That's one thing I won't do. Like I will have like a rate I will charge. Like I would say $60 an hour is my rate. Okay, that's what I'll say. And whether I end up charging that depends. Often I'll charge less than that because it's usually just doing things to help people out. If it's a job I don't want to do, or something like that, or it's just a little job which only takes an hour, then I might charge the full rate. It depends on what it is, really. But even that's probably undercharging. I mean, I've had people tell me I'm charging too little, and it wouldn't surprise me. I mean, €65 you said there, which is more than I'm charging already. But then, I'm not in it for money. I don't do it as a job, so yeah. Well, €65. That's probably about $100, I think, something like that. I don't know what the conversion rate is right now. I think it's about 1.5, is it? Yeah, industrial's very much. There's money in it because they need the gear going, and it's cheaper to fix it than it is to buy another one. So industrial usually is urgency stuff too. So it's it needs to be fixed today. So therefore you can charge more because it's worth it for them. Is that the same engine in the Volvo 264? Okay. You have to pay to make a living, yeah, indeed. For me, electronics is a hobby. It's just a bit of extra cash, and the YouTube channel was the same. Right? I don't make any money from YouTube. All my money that I earn from YouTube goes back into the channel buying things to fix. So I don't actually make any money from YouTube at all. In fact, my main income, my main day job, supplements YouTube by quite a bit. Memberships and the Patreon supporters and things like that, and the little sponsorships I get, they help to offset the cost a little bit, but the YouTube channel costs you money to run. Friends and family have to pay, yeah, indeed. Give no guarantees. Oh yeah, okay, yeah. I mean, if I'm repairing something, I'll say that it's fixed from what I can see, but it may not be fixed. Right, I've got something recently which I've been working on, which I edited the video for yesterday, which you'll see next week, I think. Yeah, it's something you see on Friday. So it's a piece of gear which I've repaired, and well, I think I've repaired it. It's currently working. I thoroughly tested it. It continued to work the entire time I was testing it. But because I never actually identified exactly what was causing the problem, I don't know for sure that it is fixed. And so I said, well, I'm charging you for this because it was actually a custom job for someone. So I'm charging them, but it may not actually be repaired. I've given them a heads up saying if that's the case, then just send it back and I'll have no go at it. But that's fine. But sometimes I'll just say it is what it is. This is the risk you're taking. I can't promise it's fixed. But sometimes I feel much more confident about it. I'll say, oh yeah, it was this, and I've sorted that problem out. Sometimes you just don't quite get that certainty, which is unnerving, I suppose. I'd much rather have a situation where I've found a problem and fixed the problem, rather than working on a suspected problem and fixing the suspected problem without any proof that's what the problem was. I don't like those situations. Some customers complain that you fixed it 3 years ago, now it's not working again. Yeah, I've read that. I actually had someone come back once. I'll tell you a little story. When I was doing CB repair stuff. This is 25 years ago, or thereabouts. I fixed the radio for someone. It was being twiddled with inside CB radification. Now there's lots of adjustments, inductable adjustments, like metal cans with inductors on them, like ferrite cores. And I'd been through, repaired a couple of minor faults of the radio, readjusted the whole things, put on my test gear, settle up, get it all adjusted properly so it's all as it should be. Receive and transmit frequencies, that sort of stuff, all done. Give it back to them. Like 3 days later, they came back saying it was no good. And I looked at it and said, well, you've been inside it. Because I used to put a seal on the outside and I could see if someone had been inside a radio. And sure enough, they'd been inside it. And also I used to put wax inside the adjustments so they wouldn't unadjust themselves from vibration, mobile situations. Or I would also be like a witness that someone's been fiddling with it. And every single adjustment had a screwdriver shoved into it. Every single one of them. It's like, oh, I'm not working on this again unless you pay me again because you've been messing with it. He goes, no, I haven't. I said, well, yeah, you have. He's lying to my face. Anyway, I gave it back to him and told him not to come back. Yeah, just not worth it. Having someone like that as a customer, not worth it. Yeah, and industrial repair stuff, yeah, sure, you've got to do lots of thorough testing and proving and safety checks and all that sort of stuff. I mean, you should be doing that anyway, but it depends on what you're working on, of course, but I'm sure there's lots of things where you have to be really thorough. Expats with software problems in France offer a bottle of wine. Yeah, I suppose wine's, what you're going to get in France, isn't it? Hey, bit of hobbyist. Everyone's kept starting with that. Well, you need to get you a little bit earlier, mate. Can't give 1 year warranty on 15-hour equipment. Yeah, well, depends on what I'm doing. I mean, if I'm confident that the thing's good, because often I'll do like a bit of a refurbishment to make sure it's going to last a while. I'll actually go over the circuit board and check for bad joints and fix everything I can see, not just the thing which is the current fault. anything which I can see could be a potential problem in the future, I will fix those as well, and I'll go across it. Not within reason. I'm not going to like replace 100 capacitors for free, kind of thing. No. But if it's like bad solder joints or anything that looks a bit dodgy, I'll do those. Even if they're not currently giving a problem, I'll do those to try and prevent a future problem. I know it's not good for business in a way, like, because then you won't get it back, but then you don't want it coming back under someone saying, "Oh, you did this wrong" or whatever. Yeah. Charging in tacos, eh? Yeah, so you could say I charge in M&Ms. I quite like M&Ms. Peanut M&Ms. Garage replaced your service battery until it's like your clutch went. Yeah, that's funny. I'm sure they found it hilarious. Some people would have taken it completely seriously, though. Some people would have actually genuinely believed that when I did the battery, it damaged the clutch. There are people that are like that. Yeah. I mean, this is one of the reasons I'm not doing CB work so much anymore. I've had emails from people asking me to do CB stuff, and I haven't even replied to them. Because part of it is the amount of time that's required. The money that I would charge for doing that work is minuscule compared to the time it involves to do that job, right? In most cases, like repair work and like that, it could take me, a few days, maybe a week, to dig into a tricky problem on a radio. If it's with something unusual or a bit quirky or a bit hard to find, it could be many hours of work, and yet I don't charge $60, $100, because anything more than that, it's not worth charging for, because the radio isn't worth it, right? So there's no money in it. So trying to spend dozens of hours diagnosing and fixing a problem on an old radio, it's just hard to justify. Like years ago, I was happy to do that because it was my hobby, and I had the time to do that. I would fill in my time sitting there tinkering radios, fixing them, and that's what I'd be doing. I didn't mind that. I was helping people out and what have you. But now my time is more challenging. Right? Trying to get time to do anything is challenging, and so I don't want to waste a few days in a week working on a radio to make $50 or $60 when I've got other things I need to be doing in that time. So that's taking priority. Like YouTube is a priority rather than fixing radios. So yeah. What's not funny is the quote between 200 and 1200 to fix it. Yeah. Yes. Anyway, that's part of the reason I did this channel, right? Because for those that haven't been here before I mentioned this, I think a lot of you may have been, but when it comes to doing the CB stuff, the reason I started doing this channel was actually to document the CB stuff I was doing. That was my intention, because I'd find that when I was doing a CB repair, I might get the same kind of fault over and over again on a particular type of, or particular model or circuit board design. I'd get the same kind of fault, and I could more quickly fix them because I've seen that fault before. I know exactly what that is, and I can fix that fault in 5 minutes. And sometimes, part of the reason we're doing this channel was going to be to do that and actually do videos on fixing these problems and going into these things. But yeah, again, I kind of went into a different tangent. I went away from CB stuff and I got into doing test kit. I just found that more interesting in the end, and yeah. And I've still got CB stuff to do. I've actually got boxes of stuff out in the garage there. I've got boxes. I've got a dozen, 15 radios out there which I need to fix, something like that. And I've got a gear set up out there. I've got a test gear bench out there for doing radio work, and I've shown it I think once or twice in videos, maybe. And yeah, I need to actually go out there and sit down, clear a hole for me to work in because it's just packed full of stuff right now, and sit down, do some radio work. I really should do some. I've got 5 radios sitting on the bench out there right now, waiting for me to get around to, you know, getting the motivation to sit there and do them. Yeah. Then I've got boxes of them as well, so yeah. Are we working on a CB radio today? No, we're not. No, we're not. So, had a bit of a waffle for 20 odd minutes. Let's fix some stuff, shall we? So, let's change camera views. We shall get the recording camera going because I want to record video on this, because it might be a nice general item for people to work on see repaired. More mainstream. Mainstream's good for views. See this very unique test gear kind of approach where not many people are interested in test gear, so it's a very small audience, whereas more mainstream stuff is a winner. If you can get the videos out there. Right, let's change views. Let's go to this. Hopefully it's up. Okay. Wait, try fault finding when equipment on the aircraft sitting on the ground waiting for parts. Yes. Yes, I'm sure that's a bit of money sitting there waiting for it to be happening. Okay. Hopefully you can still hear me okay over here. Maybe it's seeing me better, I don't know, because the mic's facing this way. I will sound more distant though. I will move it a bit closer. We'll do this. Slightly closer, hopefully it sounds okay still. Right, not so echoey. Right. Hope you didn't just fall off your chairs then. Right. This is what I'm going to work on today, is this thing. Well, one of the things I'm going to work on. I've got a pile of things, like I said, we'll go through a bunch of them. Let me get my tablet running so I can see the chat while I'm sitting over here. Come on, where is it? Haven't used this in a little while, so I have to remember how to do it. Come on. Where is it? I've lost it. Hold on. Well, I'm going to find it. Usually pops up straight away. It's usually really easy to find. That's annoying. Why is this being so tricky? Right, let's do it this way. So I make sure I can see the chat while I'm sitting over at this table. Okay, now I can see the chat. Suppose CB is a big thing of me. Well, it was, yeah. I used to do a lot of it. That's where I'm quite well known as doing CB stuff. The Radio Mods website. The annoying thing with the Radio Mods thing, right? When I first set the site up, I actually ordered radiomods.com as the domain name, right? So, problem is, I couldn't pay for it. My credit card thing wouldn't work for some reason. And it ended up expired, and then I couldn't grab radiomods.com because it was being held. So then I had to get radiomods.co.nz, which I've had ever since. But the radiomods.com one, that's now owned by somebody else, and also obviously radio related. And it's really annoying that that is my creation, and you know that name, and somebody else is using it because my credit card wouldn't go through at the time. CB handle, I don't remember. I've had several. I don't know. I don't remember. I never really used to talk it that much. Well, I did originally, many years ago. my teenage years, I used to talk on it quite a bit. I was quite into it, but then I reverted to fixing stuff instead. Right. Let's get this thing recording. Let's get a picture of this. You want more mic gain? A bit quiet, is it? Yeah, okay. I'll turn up slightly more. Okay. Hopefully it's slightly better than like that. Two-stroke, right. I don't know what I used to have. I had Full Guy for a while. I think it's off a TV program. The Repairman. I don't know. Hoverman. Because I had a hovercraft. I was a bit younger then. Anyway, I've had several. Right, today we're going to look at this Merlin Gauge drawer opener. Apparently it's dead, and you can probably see the button here is a bit yeah, so we'll put it apart, have a look. Apparently someone's already opened this up and had a look, and well, actually I know they've already opened it up and had a look, so we shall do the same and see what's going on with it. I don't think it's just a button, press button. I think there's actually a mechanical issue with the actual circuitry as well, so we'll get that part and have a look. Okay, I can leave that in. If you're interested in repair videos, make sure you go and check out the other stuff down below. Give the links down below in the description. Other things I fix. Okay. So this is skew width because the frame's snapped here. That just needs re-gluing. That's not hard. I'll fix that problem. Oh, okay. Button is knackered. That is not clicking at all. That feels pretty awful actually. That's not even... There's no sign of clicking on that. Is this battery got any power left in it? Here's only battery power. Battery has to... Oh, you can't even see that on camera. Yeah. So battery still has power, 8.7 volts. That should be enough. Which means even if the switch is being constantly pressed, it's not flattened the battery completely. So that still works. Right. Right. Could use a bit of clean up, a bit of flux on there and stuff like that. Dip switches, don't forget the switches, right? If I knock these switches, it won't work anymore. Okay. Note the switches. Yeah. There's that angle. In case I knock them. That wasn't quite made up. Someone else could also knock them, who knows. Right, well, that switch doesn't work. That is not clicking at all, so that needs to be replaced. We'll start there. And it's a nice common switch, not a problem at all. Single-sided board, cheap circuitry, I suppose. So these are probably a 300, so right there, 303 or 339 megahertz. Okay. What's that crystal there? 3.58, so that's a clock crystal for the chip. So somehow it's getting one of those frequencies. So it must just be relying on the oscillator circuitry, and obviously that's tuning over here. So it's probably just a capacitive oscillator sort of thing. Anyway, yeah, let's replace the switch first. Had a gauge job and someone changed the dip switches. Oh yeah. Oh dear. Sorry, they're in the chat. Hey Fred. Right, let's get some switches. Naturally I have some. Be some of those ones. So what height is that one? Yeah, two-stroke could certainly be considered having different meanings. Yes. Right, so that looks like about 5mm if it's not collapsed. 5mm. That one there. Yep, looks the same. Actually, I should do this video, shouldn't I? So I've got this little kit here of, you know, switches and assortment, and these are done in height. And the height is actually from the base of the switch to the tip of the flanger. So you're not quite sure how to work these out. So in this case it'd be like there. Okay, that height there. Kind off, right, 5mm. That's what you want. Looks like a resonator. Well, yeah, it kind of is a resonator, isn't it? But it's 3.58 megahertz. So that's purely used for the crystal. Now, what it actually is, there's a, let's get closer. Explain what these things are based on my knowledge, which could be wrong. So these little resonators here got 3 pins on them. What it is basically a crystal, but it has capacitors built into it as well. So it actually has capacitors on each side, and the middle pin's usually ground. Right, so the left and right pins are the actual connections for the resonator section, and the middle pin is ground, and you have a capacitor, usually 20 picofarad or so, between each of those right hand and left hand pins and ground pin. So it's like built-in capacitors. That's often what they have. And if we look on this side, so ground is there. Is that pin there? Thicker trace? I believe that'd be a ground trace. Alright, so you've got the solders there, solder pin there, and sure enough, the back wire goes to it. Well, these switches are, like, to answer your question, Kyle, it's a standard form factor. Right, this is a really common switch, momentary switch. They all are basically exactly the same. I haven't come across any of these which are different. And the only thing is really is the height, to make sure you're not having issues with the actuator mechanism which is pushing these things. In this case, it's this blue button housing here, so it's kind of push on that. It's probably on that point right there, I'm guessing. If you have too much height, obviously you'll be pushing all the time, and not enough height, it may not push at all. So that's what you got to get that height for. Alright, let's get some soldering equipment running. Get some rubbishy tweezers which I can use the lever to switch out with. Now, because all the soldering is on this side of the board, it's a bit trickier. If it's on the back here, it's a little easier actually. There's nothing to desolder on this side of the board. Just adjust this slightly. What we set to here? 290 I'll do. Right. So, because this is soldered on the top side, not on the back side of the board, it's a bit harder because there's nothing to desolder on this side. So I have to desolder from this side, which means I can't just get like the desoldering gun on the legs and desolder them and then pop the switch out. I've got to desolder this with a soldering iron and just try and lever it out. I mean, you could also, another way I could do this is to cut the legs off. That might actually be easier to do it that way. So we might actually do that. Just cut the legs off. We know the switch is bad. We know we have a replacement. So let's cut the legs. Then let's desolder each one individually, and that should actually be easier. Right. Make sure we're cutting right through these legs with this. There we go. Can't quite get that one. Okay, here we go. Sometimes cutting through the legs is the easiest way to get something out. Sure, it's destructive, but we're not going to be using the switch again, right? It's definitely knackered, and I definitely have a replacement, so there's no point worrying about trying to get it out intact. It's just no pointless. This is pointless. Actually, let's get a stand to put this thing in, so I've got a platform which isn't going to wobble everywhere. Hey Fred, you said the same thing. Cut the legs and cut the solder out. Well done. Let's use this. I do actually have another one I could have used. This one I tend to use the most though because I quite like it. And maybe now I will use my solder sucker because it will work better for this. See, I pick the legs out there. I still need to clear the holes out. Actually, just record video before I get committed to this. As Dave once told me, it's all about the framing. I remember that when I visited him in Australia. He said, watch out for framing. So he actually specifically said to me. Well, that leg's gone completely. Because he fell out the back. Come on, there we go, that's that leg. That one's disappeared as well. There's that leg. So I've got two of the legs out. soldering gun. Now, are they clear? They are. So, switch, pop this on this side, just like that. Nice simple repair, isn't it, this one? Put it back in the holder since you've got the holder sitting here. Now I'm going to use this gigantic solder, which I've been using for years. It's almost gone. I'm trying to get rid of it. Got some much nicer stuff now. When you're soldering these switches, don't put too much heat onto them, because you can damage the insides. Just get just enough on there to do the job. Now soldering this a little bit awkwardly because of the camera. Normally I'd be a bit more straight onto this. Here we go. Switch is in. Now let's get the battery, hook that up, see if it actually just lights up the LED when I push the button. It does. It is lighting. Right, now we can go to a spectrum analyzer, see if there's any output. And I wasn't recording video then, because I'm an idiot. Anyway, I recorded. I forgot to record that, but anyway, so I just forgot to record me soldering the switch on and discussing how important it is to not put too much heat into that switch and that sort of stuff. Yeah, I'm an idiot, I forgot to do that bit. So, anyway, the button is working, right? The LED is lighting up. So I'm going to chuck this on a spectrum analyzer now and see what output is. Make sure that the output is definitely there in case there's some other problem going on. And we also clean up the flux on this side. Now the problem is with cleaning flux is it can affect the tuning. Now our circuitry does not like having flux left on it, and the fact there is flux left on it means there's a good chance that if I clean it, it will affect the tuning and throw it off. So if I can test it first, find out what frequency it's actually operating on, where it's tuned to now, I can clean it and then make sure it's still on the same frequencies. Because flux and RF gear do not mix. Okay. Yes, it's New Year's Eve for Scott. Yes, it is. And yes, you can do that with the long shafts, where you can just tip them instead. I've done that myself. Very convenient. Let's put this away. Now, which spectrum analyzer should I use? Should I use a Siglent or should I use a CMU 200? Ooh, decisions. Oh, let's push the button on something. Okay. Hey Fixer, how's it going? Been watching since COVID. Awesome. That's what the channel's about, is trying to, you know, convert information and learning, I suppose. Share it a bit. I mean, I don't know everything. I'm nowhere near it. There's guys such as Ian, who's on the chat there, who knows way more about electronics than I do, and probably will ever will. But I have a knack for fixing things, and I just like to share what my experiences are, I suppose. Right, and the more I go along, the more I'm learning, and as it gets better and better. It's great. So, which spectrum analyzer should we use? Should we use the Siglent or should we use the CMU 200, the Rohde Schwarz? The Rohde Schwarz already has an antenna on it. I'm inclined to go to that one. Let's fire that one up. I haven't turned it on for a couple of months, so it's nice to turn it on occasionally. I think I used a Siglent a couple of weeks ago. the Rigel. I don't have a Rigel. I don't have any Rigel gear. Not even one thing. If Rigel ever watch this, get in touch. I wouldn't mind actually trying some of your gear out. I'm not going to buy it because I don't need to buy test gear. Generally, I've got everything I need. I think. If I'm buying test gear, it's buying broken stuff so I can fix it to make videos. Do I have a tiny SA? I do have a tiny SA. In fact, I've got a couple of them. I think I've got 2 of those. Yeah, I've definitely got one. But anyway, we'll do the CMU200 because that's a bit of a beast. I think it might ought to be configured correctly for this too. So to change the frequency span. Because I think I had peak hold sit on it already, which is what you're going to need to do in this. Okay, let me just move the camera around and we'll move my chair out of the way so you can see. I can get the camera positioned. Ceramic resonators are cheaper than crystal. Yes, they are, by quite a considerable amount. But application wise, usually it doesn't actually matter. It depends on what they're using for. Obviously, sometimes you do want a crystal and you want either accuracy, but sometimes a resonator is perfectly fine for what you're doing. Here we go. And of course I've got light reflecting on the screen. Let's adjust this then. Get a close up view of my messy shelving. Here we go. And I've just lost the connection. It does that. The problem is cable. I think I need to replace this cable. Is it going to come back on? Sometimes it comes back on, sometimes I have to restart the camera because it mixes it up and misses it. Let's start going to restart the camera. I need to do something with this cable. It's getting, I don't know if it's the camera socket or whether it's the cable itself. One or the other is dodgy. We'll come back in a second. Let's reboot to the camera. I've tried using the offset in the socket to see if that fixes it, but it didn't. Come on. Here we go. You get the logo in there, don't we? Okay. Chat again. You don't own a spectrum analyzer. Well, even the little tiny SAs which have been mentioned, they're actually not bad little things. They work quite well. Even if you got one of them, it'd be better than nothing. Actually, I've got 3 spectrum analyzers. I've got the CMU200, which we're also looking at. I've got the Siglent SSA 3021X Plus, and I've also got an HP 8590A, I think it is. I did a video about that one years ago. Okay. Slightly better device than a tiny, yeah, just a little bit. I picked this up years ago as a faulty unit and fixed it. So luckily the fault was relatively minor. Just a reference oscillator issue, I think. Remember rightly? I can't remember now, actually. But yeah, it needed a slight repair. It wasn't anything particularly troublesome, but it was quite good. I score copped on this one. Okay, spectrum. Analyzer settings. Let's do a span of, let's do 30 megahertz, and we'll do a sensor of 315. That should be fairly good for that range it said it could be working in. Okay. I think I've got a peak hold on this, looking at this, which is good because that's exactly what I want. Let's push the button. There it is. So yeah, it's definitely outputting something. Marker, peak marker. So it's sitting at 303.220036 megahertz. which you can see just there. So that's working fine. So I should be recording video on this, shouldn't I? Not just talking to you guys. Didn't take the hint to send you one. Well, that's true. Alright, so I've got the CMU 200 set up here. As you can see, I've got a spike here. Oh, you've missed all the setup stuff. Should I record that again? You reckon? I don't know. Maybe. So analyze settings. We've got a central 350 MHz because that covered both frequencies of 303 and 300 and what does it say it was? 339. 303 to 339 are the two frequencies this thing operates on. And so it's at 315 with a span of 30 MHz, so I can capture the whole range. And then I push the button and we've got this little spike pop up because I've got peak hold set. Right, so it's going to capture a peak and that's it. So that's what we're getting, and the markers is showing 303.220036 MHz. So that's what we're getting right now. Whether that is correct for what it's supposed to be on, I don't know, but that's what we're getting. Now we have that reference frequency there, and we know where we are, we can actually bring this in a bit closer. We'll make the span a bit less. Let's go 5 MHz. And we'll set the center at 303. Right, and we'll do the same again. Here we are. Look at all this noise here from this unit. Look at that. Some quality there. Anyway. Yeah, I'm pretty sure that mess isn't supposed to be there. But that's what we got. I've already put an SSD in this and I did a video on it. I've already done that. I've taken the original hard drive out, cloned a SSD into it and running off that. Speed wise it made almost no difference. I think it was literally 1 or 2 seconds boot time difference. It wasn't much at all. And obviously now it's got an SSD and I've got the original hard disk as a backup. So if it were to fail, at least I've got the original hard disk. I can just re-clone that and put the clone back in. I've heard my name set up YouTube as Dave. Yeah, Big Clive. Yeah, I'm friends with Dave and Big Clive. Or Clive. Okay. So that's what we're getting there. Now, what I want to do, I'd like to not have this mess here, to be honest. Let's just do it again. So you can see those little pulses coming through here. That could be something to do with the modulation. They do look interesting. But usually you get modulation, it's on both sides of the carrier. I don't know, it could just be the way this is working. Likely that's all it is. So back to the markers again, find the peak. Now we're a bit closer, we're seeing 303.1704 as that peak there. Just going to hold the button down for a while and let it transmit several times. Now I'm getting these little pulses everywhere. If I keep pushing the button, I'm getting these random pulses in places. Could be as it starts up, it's a bit noisy, maybe? I don't know. Maybe it's just a bit unstable. It's not wonderful. Well, yeah, it's the thing now, it could be bounce, it's possible, but it's just randomly popping up, isn't it? So maybe I'll come back over here to the analyzer. I'll make the span a bit wider. I mean, not that, let's do 10 MHz and let's see if it goes out any further than that. I didn't notice it before though. But there you go, that's what we're getting. Very interesting. So I zoomed in a bit closer here. I'd actually do 5 MHz bandwidth now, but I thought 10 MHz shows it slightly better, really. And we're getting this interesting drop off here on frequencies. It's quite interesting. It's not quite what you expect. Let's do this again. So you carry over, then you've got that other bit filling in. It's probably like modulation or something like that. Maybe it's using FSK and it's causing a shift. FSK is frequency shift keying. Could be that. It probably is FSK actually. Anyway. Yeah, so it's working, but that's what we need to know is that carrier peak there is marker, peak again, 303.07. Yeah. We'll see if I can get much closer than this actually. 2 MHz. Let's get more precision. Marker, peak, 303.126. I mean, it ain't perfect, is it? In that region somewhere. Let's go narrow again. Let's go narrow again. So you can start to see the actual waveform here in the carrier a bit nicer. Let's just shift the center up a little bit. Quite a bit more. I don't know, but there you go, you can see the waveform quite well there. Anyway, so we've got this broad plateau here of the actual carrier. So, do another peak. It's not quite where I want it, but it's ish there. Yeah, center peak. So 303.144, we'll go for that. That's looking roughly in the centre of that spike there. So I'll give this a clean the flux off, then we'll make sure we're getting something like that again. I could turn off peak hold, but it's a pain on this thing. Right, let's give this a clean. You won't be able to see this obviously, because I'm not going to adjust the camera for this. Might take me long to clean it. And we'll see if it changes. It could well change. My experience was that flux and radio circuitry do not mix. It's a bad thing. Flux will mess them up. It affects the tuning of circuitry. I actually had a radio once that didn't work at all, because someone else had been in there and left his flux everywhere. And when I cleaned the flux off, it started working. Because the flux was killing the oscillator. And obviously they didn't realise that that's what the problem was, because they're obviously trying to troubleshoot the thing. And they never actually got it working because they didn't think to clean the flux off. Obviously they hadn't come across that problem before, I'm guessing. Anyway. Yeah, I could enhance the resolution on this sort of stuff, and I can do all that sort of stuff. It does slow the readings down quite a bit though. I just wanted to get a ballpark figure of where it's sitting, because this will not precise anyway, right? It's just got that oscillator there, 3.58 MHz oscillator, and it's obviously using a mixer system in that IC to generate the frequencies a little bit, and also you've got the capacitive inductive tuning. So it's not precise anyway. I mean, all vary with temperature. It is never precise, so it doesn't matter that much. This has to be about right to make sure that we don't mess it up by cleaning it. If I work on something for someone, I'll give it back clean. The other thing I've seen as well is the actual antennas on these things, because they can be, because it's a circuit board antenna. It's on the actual PCB, etched into the circuit board trace. Much like to do for things like ESP32s and stuff like that. Yeah. Exactly the same sort of situation as that. But sometimes they can be affected as well, strangely, if it's particularly bad. But basically, if you've got flux on a RF circuit, it's usually a bad idea. But also involves doing like I've just done this, is to not clean the flux off until you know exactly what you're supposed to be getting, in case you mess it up by doing that. Okay. So I've cleaned the flux off the circuit board. I'm not going to refresh the screen yet because we know what we're getting here. I'm going to push the button and we're going to see if it's changed. It looks exactly the same. That's brilliant. I'll have to retune it. Where's it gone? Stop sweeping. Oh no, it's gone. Look. Maybe that's why it didn't change. It's died. So, maybe it did change a lot. Let's increase the span. Let's go 5 megahertz. There we go. It shifted by a lot. Just by cleaning the flux off, doing nothing else. Peak. We changed by 1.5 megahertz by cleaning the flux off. Told you, flux and RF circuitry, not a good mix. Now this circuit board does mention 303 megahertz, so I'm going to retune this thing to be exactly 303. Turn the board over. I need a ceramic tuner for this. Let me get one. It fits. Right. So we need to bring this up. That centre's still the same, isn't it? Yes, so we need to bring this over to the centre over here. And now I'm touching the circuit board, so it's affecting things. And that tuner is stuck. Yeah, it's got it moving. Didn't want to use a ceramic to get it moving because it's a great way of destroying a ceramic. Actually, I will turn off this peak hold. Levels. Where is the peak hold? I've got to remember where it is on this thing. Where is peak holding? I don't remember where it is. I always have trouble finding it. Always have trouble finding it. Yeah, at least it's all that bandwidth there. Tech mode, OMS, edition, continuous, display mode, maximum, average, current. Let's try that. There you go. That's where it is. And let's come back over here. There's a noise there, it's interesting. I should have pushed the pull span slide. Right, 303 is what you want, 303, and span of 5. Bandwidth 10 kilohertz. Ready? Okay. Let's try that. 10 kilohertz, is that enough? There we go, it's a nice spike. Let's keep it wider, make it faster. Let's tune this to be 303, hopefully. which is about there, somewhere. There was 303.12 or something, wasn't it? It did change around a few things. So let's go back to markers, peak. Even like you can see it drifting. But that's 303.18. That's pretty close. I think it should be exactly 303. That's what I'm thinking it should be. 303.09. 302.95. Gone too far. Here's when I take the screwdriver off, it changes. Feel 3.08. Yeah. Ish. 0.44. It's still basically where the original was, right? So I think I'll be happy with that. I reckon it was good enough. Check the chat. I didn't spray any cleaner at all on the component side of the board. I only sprayed any cleaner. Well, I didn't spray anything. I just used IPA. I dripped some IPA on a circuits board on the trace side of the circuit where all the flux was. Right, so that's the only bit I put flux on. Was on that side there. Put cleaner on that side there and clean the flux off because it was covered in flux, and leaving it on there will cause drift over time and all sorts of problems, but you saw how much it changed just by cleaning that flux off. And I was using a bit of towel as well, like a little absorbent pad thing like this to clean it as well, so it's all dry. Water isn't wet until you touch it, yes. Right. So let's move this thing closer. I'll zoom out a little bit. Oh, out's the other way. I keep getting it wrong. Unit here. There we go. Right. Peak is there. 302.74. Now my fingers are right in the circuitry there, so I'm likely to be affecting it. So we'll move the fingers out of the way. And try and hold it at the same time as we move the fingers out of the way. Peak is now 303.26. So just holding the board changes it by quite a bit, which is not surprising. That's quite normal. Well, I've got to make a video about ferro wires explaining why I need to buy test equipment for the test equipment. Yes, anyway. Right, let's put this thing in the casing. And we'll retest it. So, put the LED back through there. Still need to repair the actual button itself. But being in the casing means it won't be affected by my fingers, hopefully. Come on, sit down. Okay. Let's try this again. And having it in the casing has shifted it again. It's now sitting at 304 megahertz. Just having it inside the casing. Having the casing around it has shifted it off. But so that's what I cleaned, is this mess, all this side. Right, that's what I cleaned off, is all that flux that was all over the switches and all around here, and obviously the bit up there. Right, there's still a little bit just over here, but that connection there, didn't quite get it all, but the antenna had some on as well, just covering it. And because these use a tuned system, anything on the antenna can affect the frequency tuning as well. So the antenna is part of the oscillator and the actual resonator circuitry. But having it inside the casing is throwing it off, which is annoying. Maybe I can do it this way and try and push it. Can I push it? A bit so you can see what I'm doing. So I'll try and get it so I can hold it down. Just use a ceramic. Let's do that. Yeah. So what I'm going to do is tune it now in the casing like this, because this is affecting the tuning. So I'm going to retune it like this in the casing. You won't be able to see what I'm doing. That's why I pays to double check these things. Mind you, the original tuning was with it out of the casing, wasn't it? Right, it's on 303.05 right now. So let's put the top cover on and we'll see if that changes it again. It might. That's about the same. That's actually okay. Now, we need to fix the button still yet. Got to put some glue on this to repair that bit so this doesn't keep pushing over sideways. Check the jack. To secretly break something for the wife and explain that you need a bit of gear to fix it. Gauge door opener. Yes, it was a gauge door opener. You have control to mute the wife. Very expensive. Expensive and sought after. I don't know. Right. Some crappy glue. Right, so when I put this thing back into the housing, it did affect the tuning a little bit when I put it into this side, which I was not surprised about. Sometimes doing that kind of thing does affect the tuning because the antenna system is part of the resonator circuitry of the oscillator, and anything near the antenna can change the tuning. So that's why I put it in the casing and rechecked it, because I thought it might change, and it did. Anyway, the board's looking a lot cleaner now. How it should have been from the factory. Now I'm going to put some glue on this little housing here to try and fix that broken button, so it doesn't keep on slipping off. Slipping off and failing. Put some glue there. Pop it down. That should be all it needs. Need that to go off, and once that's dried, it should be good as new, hopefully. Anyway, okay, I'm not going to put that back in yet. Oh, I might be able to actually. Let's see the battery out. Yeah, so I put the battery into the housing. Put it in the right way up would be useful. It's LED, you've got to get into the hole. Right. Put that there. You've got a switch on the side, which I think is just a power switch. Do you think I should check that as well? Try flicking the switch. What does that do? It's still there. Flick the switch down. It's still there. I don't know what the switch does. It does something. Yeah, I don't know. Maybe it's like a 2-button function. Button 1, button 2. Could be that. So I'm going to put the battery in yet until that glue's gone off. Because we obviously don't want to glue the battery in. That'd be a bit awkward. Okay, let's tidy up a bit. So that's that little project done. And so we've got plenty more to do. So that's a nice simple one. Simple sometimes nice. Have a break from the complex stuff. Okay, I'll chat again in a second. And I'll turn the CMU 200 off. I'll push the button one more time. Just double check it one more time. Yep, that's still looking alright. Now I'll turn the CMU 200 off. Okay, so things we're going to look at next. I should do a list. Let's get back in front of the computer. Turn it off a bit. Okay, back. He's ahead. Right. Okay, now, so things we'll look at next. It's quite good I was able to demonstrate the flux issue affecting the tuning of the circuitry. I've had people debate that with me in the past. Oh, flux doesn't do anything, it's harmless. Well, my experience has been different, and I was able to show it then. That's quite good. Alright, how do I do that on here? I always have trouble finding this. Poll. Start a poll. Start a poll. If I could type, that would be great. That's what I'd like to do next. Add an option. Yeah, okay. I'm going to call it this because I can't speak Russian. Or whether it's Soviet. It's Soviet. That's three things. Where was the cat today? Yeah, it's around. And what the hell was I doing with that thing? I've actually forgotten what I was doing with that. I might have even looked at it already, maybe. Right, this will do. 4 options, that's all it's got. So that's what we're going to choose from. My preference is the DVD player because I want to get rid of that. YouTube Flux. Well, yeah. I actually don't tend to use Flux that much unless I really need to get a nice finish, or if I'm doing surface mount stuff. I don't tend to use Flux that often. Like through hole, I don't usually use Flux unless it's a bit corroded and stuff like that. Surface mount, I'll often use Flux because it helps the process quite a lot. Guess Cat's still there, yes. Guess Cat's still here. I don't know where he is right now. He's about out and about somewhere. Can you tune your cat's whisker? You could, but the tricky bit is getting the cat to stand still. Dropping the silliness now. Right. Let's look at the poll. What's the poll doing? I'll end the poll, so we'll look at the poll. Oh, it's all pretty even right now. Go on, everyone. Vote in the poll. As long as you vote for the DVD player, I'm happy. Everyone's going to vote for something other than the DVD player now. I've been working on my motorhome for the past week. I've still got to do like another week's work on it. I had to repair some rust on the roof where there's a vent. I actually did record some video. I've recorded a video about it. I might maybe show it, I'm not sure. Where it's like a roof vent on the top of the bus, and I noticed some rust creeping out from the back of it underneath, like they had like a cover over the top of it, and I noticed some rust creeping out along the paintwork. It's like, okay. Now I knew the cover had rust around the edge, and I've been sort of trying to keep that under control because I couldn't get the cover off because it's got 3 bolts to hold the cover on, and they're rusted in place. I couldn't get them off, so I didn't really want to disturb it. You know, I got to the point thinking, well, there's rust creeping out from underneath the cover. There's more going on than just the edge of the cover. So I drilled the bolts out, took the cover off, and found that it was a mess in there. Lots of rust. I did post a little picture, maybe it was a little video. I did a little video on my Patreon page, I think, just showing that bit. So I did that, fixed that up. So I'm confident that part's good now. And then I've also put new seam sealant down both sides of the roof because it's got a seam right down the roof because it's a 7 metre vehicle, 7 metres long. So it's got obviously panels which join, and it's got seams right down both sides. And I'm suspecting that they may not be perfect anymore. So I put some new seam sealer down each side of the bus on those seams to reseal those, and then repainted those. And then I've been working on replacing the window seals. So this vehicle, it's 25 years old. No, 27 years old. And the rubber seals that go around all the sliding windows, because they're all big sliding windows, they're all shrinking right from age. The side which is on the side of the sun has shrunk a lot more than the side which is parked away from the sun, and so they're shrunk like this much. In some cases the corners are cut off on the windows, so the rubber seals are pulled out and it's essentially in front of the glass, like that. So I spent $1,200 on new seals for all the windows. The problem is, to replace the seals you've got to take the entire window frame out. You have to cut through all the sealant which is holding on the window, because they're basically glued on with mastic. So I cut through all that, and that's a messy and hard job in itself because it's sticky, it stays sticky. And then you've got like 6 clips you've got to take off each window as well, and then you can lift the window out. and then you got to strip it all down, take the glass out, put new seal in, rebuild it all, and glue it back in. Done 3 windows in a week. Well, basically one a day. I can get one a day done, and it's outside, and I don't agree about it outside. I tend to get sunburnt. I've got sunburn a little bit now for being out there doing it, but I'm doing it in the morning and trying to get as much shade as possible and that sort of stuff. I'm not an outdoor person. I'm an indoor person. So yeah, I've been doing that. I've been doing some video about it. I might show you a little bit actually. Just to give you an idea what I'm talking about. Let's find a bit, and I probably won't have any sound on it though. I don't think the sound will come out. Let me just get this in the top screen so you can see it, and then I'll share the screen with you. Let's try and find an appropriate clip. Actually, I'll flick through all of them. Alright, top screen. Here we go, and I'll put some sound on, but you probably won't hear it. This is a clip I showed on Patreon. So that's the vent I showed to fix. Yeah. All the brackets are rusted out. There's a piece across the front of that cover which is rusted out. And yeah, the brackets are gone. There's like one bracket which is only half there, the very front one there. It's almost rusted right through. So that had almost nothing holding on apart from the sealant I put around it previously to try and stop water running in there. Yeah, as you can see, that's a mess. So I had to fix all that up. In the wrong thing, so it's jumping around the wrong place. There's the bits which I cleaned up. There's the bits of rust which have used to hold it together. And there's the top when I was cleaning it all up. Ground it back, got rid of the rust. Rust treated it. Yeah, it's rust treated there. So you have to grind it back to get clean metal. You have to get away from the rust. So you have to get. You can't just only have the rust exposed. You have to go back to clean metal. Otherwise, it's underneath the paint and it will just keep creeping. So did that anyway. So that ended up being done. And that's the inside. How to get it out. Explain how to take the roof out. So I've done a video about it. I'm going to actually turn it into a video or not. There's the windows. There's Mrs. Defpom cleaning, trying to get the sealant off the side. Tedious job. So yeah, you can see her taking the window out there, and yeah, it's fun. And there's a window there in the garage. Yeah, that's all the seals we've got to put in. There's some more. There's a window done. Next window being done. Yeah, so this one had rust down the edge. So I had to grind it out and treat that. And that's after I've painted it. Filled it and painted it all. Ready for the window to go back in. Yes, that's what I've been doing. I've got to do the other side of the bus. It's done one side completely. Another window there. Try and see if we can find the other one. Yeah, there's the front window. Doing that one. It's the very front one, which is the biggest pain to do this one because it's the biggest window. And also the sealant was different, so it's hard to get it off. It's very sticky compared to the other windows, which is interesting. Anyway, so that's what we're doing. So that's what's taken up this week. So every day there's nice weather or no risk of rain. That's what we've been doing, is doing those windows. So we've got to do 4 more yet on the other side of the bus. Yeah, great fun. And as you can see, Mrs. Defpom's turned up.
Oh. Alright, I thought the camera was on your bench. Thought I was safe.
No, never safe. Okay, let's have a look. catch up the chat again. Silicon, I don't know about silicon. And Christian says, hello, Mrs. Defpom. Yes, that's a lot of work. Yes, there's a lot of work. It takes the windows which are just a take out, strip down, replace the seals, refit. That takes about 3 hours. The one which had the rust around it as well, which also had another issue where I took it to a professional panel beater and actually caused more issues than I solved. This is why I do shit myself. That one took me about 7 hours because I had to take the window out, clean up all the rust, fill it, paint it, and obviously wait for all that to go off, not well enough, so I could do it between each stage, and then refit the window. It took about 7 hours to do that one. And the issue with that particular window is that we had some rust on the gutter, and they had a fixed window behind that one, which is just glued on permanently. It's not an opening window. And we had some rust fixed on the gutter by a panel beater. So I took it to panel beater because it's a bit of a tricky one to do, because it involved taking the window out, and it's not one I wanted to mess with at the time. And I had sealant around the windows between each window, because I did have some issues with some slight leaks on a couple of windows, so I just put sealant around all of them so there's no water getting in those tops or sides of those windows. Never had a problem with leaks after that. Also, re-gluing all the windows back in again now is going to solve that problem anyway. But what they've done is they got a knife and they cut through the sealant about 20 times and cut through all the paint around the window on this fixed window. They cut right around it, they cut through the sealant and just cut all the paint, and they left it like it. When I got it back, I could see through the gap where the sealant used to be, right? Because obviously they'd taken that off, and I could see the gap between these two windows. It's a tiny little gap, a few millimeters, and I could see that it's all these scratch marks down it. It's all starting to rust, and I was not happy about that. And that's a professional panel beater. And part of my job this time, we took the window out, which is neighbouring that one, which is where all the scratches were, is to scrape all that back with a brush, wire brush on the drill. Took all that paint off that, took off all the rust because it had started rusting, even though I'd sprayed as much sealant, rust treatment through that gap as I could. I knew I couldn't get to all of it. So I had that window out and I actually scraped all that back and treated that and repainted that edge as well. So I've done a bit of video on that too. It's all in that folder too. But yeah, that one took me all day because of the fixing what the panel beater did. If they had just taken a bit of care, or okay, you can scratch the paint, we cut it through sealant, yeah, it'll happen. But what I had to do is repaint it straight away. It would have been fine. But they didn't. They just left it. So not going back there again. And Fred says, Mrs. Defpom not making you a cup of tea. No, apparently not.
Do not exist just to make you coffee. Thank you.
But my cup is empty. Anyway.
So is mine.
Yes. We can make two then. No, okay.
Which one of your friends got you in trouble just then?
That's Fred. It's always Fred.
Right, said Fred.
Anyway, right, so the poll has been running for a while at 23 votes, and it's the HP 3406A. The rust treatment stuff I've been using, it neutralises it. It does actually work, and you can actually it can act as a first coat like primer as well, so you can paint over top of that, and that's fine. Although I've been using primer on top of it and then painting, so I've got 3 layers of protection. And once I've used that stuff, the bits which have got that treatment on, as long as I've treated them and scoured the surface properly and actually removed any loose rust and got down as deep as possible into the rust, that treatment will actually neutralise it and stop it. It does work. But you have to make sure that it's not just sitting on the surface, because if you don't scrub it back and get rid of all the loose stuff or the surface rust above the main deep rust, it will just keep rusting underneath it. Yeah, anyway, no sugar in yours. And Christian says this is how one ends up on a sofa. Yes.
Christian sounds like a very sensible person.
Panel Builders a body shop. Yes, that's right. Body shop. So they do panel repairs and crash repairs sort of stuff, and that's what they do. That's their job. And some of the, like the paint work they did and some other stuff. They did some repairs on the roof as well. And the paint work looked excellent. It was a beautiful paint job. It looked like factory. It was really nice. But the rust came back because they didn't suit it out properly. They didn't actually take the rust back. I told them to do. The reason I got them to do it in the first place, the rust on the roof as well, not just on the gutter but also on the roof, was because it was in a seam. Right, so I wanted them to clean that seam out, treat it, or maybe cut that out and replace it, and then obviously fill it all and repaint it. Right, that's what I was expecting them to do. Which is why I gave it to them to do and not doing it myself. And it turns out what I did is basically filled over it and I treated it roughly, well, kind of treated it, filled it and painted it. And it looked beautiful for about 6 months. And then the rust came through because I hadn't actually solved the problem. So, yeah, I won't be going back there. Yeah. Right, so let's look at another piece of gear. The 3406A. Now, I've had this sitting here for, God, 8 months maybe? So I don't actually remember what's wrong with it now. I don't remember what I need to do to it. But no idea. In fact, I don't think I've even powered it up. No, I don't think I've even powered it up. So, end of poll, that's what I'm going to look at. 3406A. Which means I need to dig it out of this pile. Change views. Okay. Ian, you noticed the light, did you? Yeah, I need to set this up yet. My wife got it for me for, was it my birthday?
Which?
The on-air light. I think it was
On air,
birthday.
yes,
Yeah.
for your birthday.
Yeah, so I need to get this set up at some point. I need to find a bit of space to put it there. Originally, it used to be...
Outside the door.
Yeah, originally it needed to be on the outside of the door because it was about children being in the house and making noise and I'm trying to record video and I get a bit annoyed about that. Having to record the same thing multiple times. So that's what it's based upon. LEDs sound like mine, like the one that's running in the background, like the one that shows my channel information. I made that one. I did a video on it. It's some 8x8 LED panels, little segments like this, 8 of those stuck together. You've got the built-in drivers, and it's like a serial control. And I've used a ESP8266 on that. It's plugged into it, and that is it a Wemos D1 Mini or something? I think it was. It seems familiar, and that's then wirelessly connected to the to the network to connect to the YouTube stats, the API, by Brian Locke, using that. Actually, it reminds me, I haven't heard of him, Brian, for a while, actually. Right, so, Paul Norman's given me $8, sorry, £8, even better. Thank you much, Paul. Treat myself and my wife to a coffee.
I'll order the Uber Eats now. Oh no, wait.
Yeah, unfortunately we live a little bit far away from anything, so...
Fine, I'll make a coffee.
Yay.
Oh my gosh, pressure, peer pressure.
Well done, Paul. Good on you. I don't know. Right. Let's try chapter chat again. Ooh, right. So the remote controller's fixed.
Oh, cool.
I think the glue's gone off, so I can put the battery in. No, not quite. It's not very good glue, that one.
I'll let Stacey know.
Right, let's make some more space here. I think I might turn off soldering equipment until I know I need it. There's a guy that's got another kind of grabber on eBay for this unit. It's this style grabber. It fits on the end of this. It's very unique. I haven't seen this before. And so it goes off there like that, and it goes on here like this or something like that. And it's a different kind of grabber, but it's a bit expensive. I'm just wanting different tips for this thing, but I didn't want to commit to getting it until I knew this thing even worked, so I haven't actually done anything with it. Well, look at that. Okay, let's change camera views again. We'll get this big camera going and go from there. Let's find out if this thing even goes. Now this was locally sourced, so it's probably on the right voltage and stuff already. I don't know if I've even powered this thing up and tried to use it. I don't remember. Maybe? Could have done? Not sure.
The kettle is still boiling up.
No, it's not. Kettle's finished. Living life dangerously here.
We really are.
Okay. So there's a TIS tag on it. Oh, operation note tag. Original one from HP, looks like. Should be using pro adapters. So some of these you can still get on eBay, obviously, but they're not cheap. So there's a Pentile style probe, which I don't have. 10-to-1 divider I don't have. I've got this one here, the pincher one. Yeah, anyway, it's got a few different options, but you can't. I've seen them on eBay, but I didn't want to commit to buying one. Buffering was a Defpom. It could be me. I will check the stream and see if it's buffering. It could be. I have dropped 58 frames. I don't think it's really me. Not with 58 frames being dropped. Since I started the stream. Often it will give problems as it goes on, and I will have to like scale back the sample rate. The frame rate. It's all twisted together. This is all. It's untangling. Oh, there's a cat running in. Big black panther. Okay. So I think I found this one online. I didn't have a tip for it. It came with this, nothing else. And I got this one online because I had nothing. Because I needed to have some kind of tip, and this is obviously a gripper one. Okay. Ooh, bonus. Got a coffee. Got a mince pie. Thank you, dear.
You're welcome.
Might have to eat a mince pie before we start. Yes, anyway. So, I don't know what the stories with us. I don't think I've even powered it up yet. I don't think I have. Yeah, I don't think I've powered this up yet. You have to excuse me, I'm eating my mince pie. I'll get this out of the way, then I'll concentrate on what I'm doing.
Awesome live stream content, honey.
Mm-hmm. So this was New Zealand Navy. This is where it originated from. I don't know how long they had it. I don't know where they got it from. I don't know the history. All I know is that this has been done by Babcocks, and this is often a result of the New Zealand Navy. This is where it's come from. So it's probably been looked after. You done?
Is that one of these ASMR videos?
Okay, now I can talk. Let's get stuck into this thing and figure out what is going on. Take a picture. One thing I've been annoyed about is that I've got these remotes. I'll show you in a minute. So, one's original, one's an aftermarket from China, and they both used to work fine. Now they don't work with the camera anymore, so I think the problem is actually the camera, because I've tested the output from these, and sometimes you can actually see them. I don't know if you can see it on here or not. No, you can't. No, you can't. But I do actually have an infrared tester, and they're definitely outputting a signal. They're both working. The camera cannot see them. Although, it started recording. When did I start recording? Maybe we're at that time. I don't know. I'm recording now. I don't know. Anyway, but yeah, they're not working. Yeah. Well, the camera's done me well for a while. I don't know how long I've had it. About 5 years, something like that. Remote snackers. I need to buy a new 4K camera. Definitely, Alan. Why do I keep calling you Alan? Ian? Ian, why do I keep calling you? I don't know what we're doing. I don't know what I'm doing. I know exactly what your name is. For some reason I keep calling you Alan. What? Why? What the fuck? Ian. Ian. Ian.
Alan.
I don't know. Fucking hell. Anyway. That's right. That's correct. Maybe that's what it is. Maybe that's why I've got that link in my head. I don't know. Alan's his dad. His dad.
Ah.
And he has told me that in the past.
Right.
Yeah.
Alan.
Alan, yeah.
Alan.
Anyway, we should get
Moving
on
on.
with this. Yes, definitely moving on. So, voltage selector is on 230 volts. That's a good start. We should check the fuse. Although I expect it to be fine. It's supposed to be a quarter of an amp. It is. So it's got an adjustment pot on the back there for some reason. Subwoofer output, recorder output. And serial number is 1722A. So this is made in 1977. I should record video about this, shouldn't I? I shall do that bit again because I'm getting distracted. So today we're going to look at this HP 3406A ball bearing sampling voltmeter. I've had this thing sitting around for 8 or 9 months probably, something like that. I don't think I've even powered it up yet. I've had it sitting on my pile of things to do. And I'm doing a live stream right now, and the vote on the live stream was to look at this thing next. So this is what we're looking at. I've already checked the fuse, it's correct. Serial number is 1722A, which means this is made in 1977. It starts with 1960, so he's added on the first 2 digits of a 4-digit number, or first digit of a 3-digit number to the 1960. So 1960 plus 17 is 1977. That's when this thing was made. Don't know if it works. Got no idea. This came from Bad Cops, which is, well, at least checked by Bad Cops, which is New Zealand Navy. So I believe this is an ex-New Zealand Navy. And even on here it says something about NZ there. What does that say? Can't quite read it. It's a bit faded. Shipyard, yeah. So a shipyard. So yeah, New Zealand Navy definitely. So it's got its tag on here, which looks like it's from new. The only thing this actually came with originally was this hand probe, which isn't actually complete. I actually managed to find one of these online, which is a grabber for it, which actually fits on this thing. So I've got an attachment for it at least. There were some other ones online which I found. I haven't committed to buying them yet because I wanted to see if this thing even works first. There's no point buying all the accessories for it if it doesn't work and I can't fix it. Because I don't even know. I mean, it could work perfectly fine. Never powered it up. So, sampling voltmeter, it does volts and decibels depending on the scale you've got set across here. So it's 1 millivolt, it looks like, because it's 0.001. I'm guessing it's 1 millivolt. Up to, I believe that's 3 volts, not 0.3. It looks like a 0.3, but I don't think it is. Yeah, close to that. It looks like a 0.3, but I think that's 3. So I think it's 3 volts maximum, 1 millivolts minimum, full scale. And we can test that range easily. I have a piece of equipment for that somewhere. Oh, this thing from Ian Johnston. Not Alan, but Ian. Now, how do I hook this up to that? Might use some clip leads or something. Am I still recording? Not right now, I'm not. Please link the Alan Chipmunk. Alan. Yes, Alan. Alan. Alan.
Alan!
Alan! Yeah. There's a guy at work called Alan, and I do that with him from time to time. I'm pretty sure I've heard it before. Mostly from me. Okay. Power plugged in. Let's do a smoke test on this, I suppose. Let's get this adjusted a bit better. No, no, the panther's here. Come on. Don't drink my coffee.
All 7 kilos of them.
This cat is huge. You're buffering again. I don't think it's me. I'm checking. No, I haven't dropped any more frames, so it must just be a YouTube thing to you. Try reducing the quality. Go to the settings and change the quality down by 1. That might solve it for you. Okay, that's it. This is just about ready to power up. Let's get this set up around here. What am I feeding the cat? Yeah, well, other cats, I think.
He must have run to the litter too, that one.
It's not our cat, it's stepson's cat who brought it back with him and left him here.
It's an oversized cat that fits with an oversized child.
Yes, the child's like 6'6" or something, I think?
4.
6'4". Yeah, 6'4", and his cat's like same kind of proportions. Anyway. That's an AC only meter, is it? It could be. Generating AC is going to be a little bit trickier. I have to generate off my Siglent generator over here. Ah, okay. Well, I guess I'll be putting the PDVS2 Mini away then, Ian. I'll leave it at the back of the bench. Repair the CD player. It's too late now, we're committed to this. I've started recording video. Right. So as has been pointed out in my chat, because I didn't read the instructions for this thing, and apparently people in my chat have read the instructions for this thing, this is an AC voltmeter, not a DC voltmeter, so me having Ian's PDVS2 Mini here is kind of pointless because it's not going to work with it. So I'm going to have to generate some AC from a different source. That's not a problem. I can generate AC from a few different sources. Whether they're precision AC, oh, I've got my calibrator the other side of the room, could always use that. It's the other side of the room though, that's the only problem. So yeah, I can generate precision AC if needed. Otherwise I just use my Siglent generator and get something around abouts right. So let's power this thing up for the first time. I've got a power plug in the back. We've got some gear over here. Let's get a closer view. So you can see the hoppy meter at the back here, or the knockoff hoppy meter. I'm not quite sure. It's a knockoff, so yeah. That'll tell us the current when we turn the power on. If there was anything going wrong before we even turn the switch on. It is currently off like that. In is off, because that makes total sense. And we'll power it up. You ready? No current draw. Good start. Wait for the smoke. Oh, the Clive's has gone live. Just notified me. Don't leave. You can't go.
Surprise for everyone.
Sure, the CD player actually won the vote. No, I don't think it did. It never wins a vote. That's why it's still sitting there after all this time. Cowport generates AC is working yet. That's right. The cowport was right there, which I need to plug this probe into to verify it. I do remember that bit. Okay, thanks for dropping by, Adam. Catch you later. I'm still recording in case I get magic smoke come out or something go wrong. Nothing, so there's probably no refills across the supply rail. It could be a filter cap still, you never know. That's why I'm still recording in case it does go bang. Right, let's power it up. That's not it. Let's push it on. Let's do 1 volt. Okay, meter moved. That looked promising. We're drawing 15 watts now. Let's go through a few scales. Let's go 3 volts. See if the current changes in case there's a short in any particular range or some kind of problem. That all seems fine. Back to 1 volt. There's a calibrate port down here, so let's plug this into the calibrate port. I'm going to take this sleeve off here. Chuck it in. It says 1 volt on the 1 volt range, so we should get 1 volt. And mind you, we've got a zeroing to do. The zeroing thing here. Let's do this zeroing. Yeah, that's good enough. Plug that into the port again. And I'm getting nothing. So I'm pushing the button on the side. Getting nothing. Well, that's not a great start, is it? 3 volt range? No. 0.3? No. Still nothing. That's just ambient noise. So, it's either got nothing on the 1 volt port or it's not sensing any voltage. Well, that's disappointing. Now you have to fix it. Well, that's not really disappointing, is it? That's a good thing. What about the cowl button, you say? Oh, for God's sake. The one, you mean the one that's sitting right in front of me? The one I didn't push? That one. This button here. So, some smart ass in the chat said, why don't you push the cowl button? So, I pushed the cowl button. Oh, look. Well done, smart ass in the chat. Ian said cow button. Not Alan, Ian. It was obvious, yes, that's why I missed it. I don't see obvious things. Just ask my wife, I can't find anything that's obvious right in front of me. Yeah, so it's doing over range there on that. Okay, so does that mean I need to adjust that to get this right? Anyone else read the manual? I haven't. Zero it. Can't zero it. Let's plug that back in there, put it on 3. And that's not really zeroing, it's just sitting up there. Must be some residual stuff. Oh, the cow's still on. That's why. I don't know. 1 volt. In cow? No? Just. How does that work? Oh. Interesting. I've broken it now. Yeah, apparently. I'm just wondering why this is working the way this is working. Because these are obviously interlock switches, right? So they all lock together. So when you push one in, the next one goes off, right? The cowl doesn't. Cow's there regardless. So it's a 1 volt cowl. I don't know. Just turn it off again. Turn it back on to anything. 1 volt. Meter sticking. There we go. Alright. Okay, we've got some issues with the meter sticking here. I was trying to figure out why it was not working anymore. Couldn't figure it out. Meter was stuck. Shove it back in there. Do the cowl. Meter is sticking. Yeah, okay. Interesting, it says 1 volt here though. So I'm confused by this now because I would have thought that would be 1 volt over there. But apparently it's not. Apparently that's 1 volt. What? Should I read the manual for this thing? Okay, Fluke, catch you later. Thanks for dropping by. Oh, Christian, stick a needle, well done. This could be a problem, isn't it? I'm not sure how easy it is to get the meter out of this thing to fix a stick of needle. Yeah, can't even zero it now. Zeroing is affecting that reading too, so it does need to be zeroed. Read the manual might be something I need to do, but so with the counter on, 0.3 should be bottom scale. Maybe that scale there, that's showing us 1.8. I don't know. It's interesting because it says 1 volt down there. That's what puzzles me a little bit. Well, don't know. Well, it seems to be doing something. Let's inject a voltage into it, and we'll see if it's actually doing anything more than just being a bit weird with the sticky meter. Let's get a AC voltage source. I'm sure I've got something I can use. Crocodile clip with banana. Let's see. Crocodile clip with banana. I've got something here, I'm sure. I've got lots of things here. I've got to find the right bloody cable. Crocodile clip with banana. Let's turn the Siglent generator on. Do I think it's been dropped? Yeah, it could have been. It's entirely possible. And there is like a scuff mark on this corner here. But it could have just been dragged on its face, maybe, I don't know. Could have been dropped. So let's get the generator set up. Let's do. Well, it's kind of doing 60 megahertz. Let's go with something a bit more realistic, shall we? Well, I can probably do it. Parameters, let's do 10 kilohertz. Set to 3 volts RMS. Let's drop that down a bit. Let's do 1 volt RMS on a 1 volt range. Output is not currently turned on. Now I've got a clip onto one end. Zoom out slightly here, right? So I've got my Siglent spectrum analyzer. Sorry, I've got my Siglent STG 2042X AWG set up to do 10 kilohertz at 1 volt RMS. So I'll hook us onto here, and we get the negative, and just touch it on there, and we're getting another. We are getting nothing. Now it's got this little button on here. I'm not sure what the button does. Touching that is also potentially doing nothing. Now we do have a sticky needle. That's going to be a problem. But right now we're getting nothing out of this. Ah, no. You know what will help? If I turn the output on the AWG. Output on. Is it on? I can't see because our lighting's draining it out. Output is on. And there's nothing there. Interesting. What I've found for getting rid of sticky needles is usually to adjust the hinge pin. So usually the hinge has got a couple of little set screws on it, and you just literally just unwind one, just a fraction of a turn, and it will just usually just free it up. It just needs to break it, and just creates slightly more gap. Sometimes that'll do it. Sometimes the needle is actually bent slightly, it's touching the meter face, or even the glass. Even I've seen it happen too. But usually it's the hinge pins and the little pivot pins in there. And sometimes it's just that you just give it a bit of a tweak and it will come right. If you put any oil in there, something like that, or some kind of lubricant, it can actually make it worse sometimes because it creates like a drag on the needle, and it can actually sometimes cause problems. So, little button controls the hold function. Right, somebody's been reading the manual. So, we do 1 volt RMS at 10 kilohertz, and we've got nothing. Let's do 10 times the input. Still nothing there. Let's wind the zeroing up in case it's something to do with that. Still nothing there. So, yeah. What to do? Always read the manual. I almost never read the manual. Maybe after I've fixed it, because I'm trying to learn how to use it or something like that, or trying to figure out how to do a certain thing. So, yes, this is doing almost nothing. Which is interesting because the calibrate definitely worked. But it seemed to be out by quite a bit, didn't it? So the calibrate seemed to work. Seriously? There, that one. It works on that one. And that's where it's stuck. So I'll try this level here. Hopefully not blow the front end out. No, that didn't work either. So no, it's not like it's just completely out of whack as far as scaling. Well, let's put it apart and let's have a look inside it. So, you have to pull this thing apart, I think, and have a look and just see what's going on inside, see if there's anything obvious, maybe do some voltage checks. It doesn't appear to be responding to input voltage, but it is responding on the calibrate output here, but in the 10 millivolt range, not the 1 volt range, and it says 1 volt here. So I'm a bit confused by that part. Either that or someone's messing with this little knob here and it's completely out of whack and it's not actually outputting the right voltage. Possible. I don't know about the history apart from it came from Babcock's and ex-Navy. So this is last cow due in 2001 is when it was due last. So anyway, we'll open it up, have a little look around inside, see if we see any problems. Well, the panel meter could be a pain to fix. Yes, it's also a pain that it's not working properly. Are you sure it's an AC meter? Are you sure? If it's DC, I sure don't need to inject DC into this thing. Now I'm doubting you guys. I actually had the manual for this. I think I've got the manual for it. Pretty sure I do, actually. Read the manual. Yes, yes, yes. Destroy the seal. Oh, look, there's another cover under it. Look at this. So this will be the top cover, and we've got another cover. A whole bunch of information about the adjustments inside it. It's nice. I'm not going to be touching any of them, but you know, I'm going to take this top cover off as well, and we'll see what's going on inside there. I need to investigate deeper. Wilhelm's got the manual too. Excellent. So 10 kHz to 1.2 GHz. Useful sensitivity for 1 kHz. Okay, so maybe my 10 kHz is about the low side for it. Maybe I'll go slightly higher frequency, maybe do 100 kHz or something. Now, because this is a kind of precision thing, I don't know if I should stick up my hands in here without gloves on. That doesn't work anyway, so what's it going to lose? Still, 50 years of dirt's probably not going to help. Ooh, shiny. Look at this beauty. Top cover's off. Look at that gold in there. Gold plate circuit board. Very nice. That's the old HP quality for you. Now it's got board edge connectors in the back here, so these cards will actually come out that way. That seems to be like a top chassis panel here, so I can actually see a frame underneath it. Maybe I need to take the bottom cover off instead and see what's under there. But on this side there's like a few electrolytic caps. Not much. There's a tantalum. Those would be electrolytic. There's no tantalum there. And there's no signs of any leaking, so they're probably perfectly fine. This kind of equipment had really high quality caps in. They might still be perfectly good. This was made in 1977. It's got like a hinging. That looks like a hinge there. This bar. It's like some kind of mechanism there. What does that do? It's got some kind of weird mechanism there. Wonder what the reason is for that. Just take the bottom cover off. Right. Yellow caps are like 90s even, yeah. And they do look more modern than the year on the actual unit. But, no, it's interesting. Oh, look at that. And there's another cover. I'm never going to get into this thing. It's got lots of screws on it here, which means I think this thing's mounted to that plate. It's also got a very slight dent here. So I was taking the bottom cover off thinking maybe I can get the circuitry on the bottom, and yeah, nah. But what I've noticed is this screw here, it's got like a, you can probably see the dent there, it's like a depression around that screw. So maybe it has had an impact. It's a bit unusual to have a dented chassis on a piece of gear like this unless it's been impacted somehow. Yeah, there is a separate plate, but I don't want to be undoing screws from this in case there's things which are actually attached to this plate on the other side rather than just the mounting plate, because it seems like there's a lot of screws for the mounting plate. Let's take a side panel off. What's the chance of being a panel behind that one? Yeah, so you need lots of shielding for gigahertz stuff. There's more adjustments. This thing is absolutely crammed. Wow. You're supposed to get into this bloody thing. Oh no, I'm just puzzled by this. Should we try the other side, or do you think it's going to be the same? I think it's going to be the same. Wow. There must be a way to get into that circuitry, surely. I mean, there's a bottom cover which has got all those screws everywhere. do I risk taking them out and have the thing fall apart? There, the DVD player's looking good now. Oh man. So now I pull the side panel off and still can't get into it. I might have to read the manual and find out how to pull this thing apart. This is getting ridiculous. Four screws each, yeah, well, yeah, that would take the top frame off. Page 7 to 2, okay. It'd be blood. I think you're right there, David. The only thing is it's got this plug-in board here. I don't know if that tips with it. I don't think it does. I think I would have to do something else with that. I might have to take the card out in order to tip it. Let's get the manual. I'm sure I've got it. Here it is. Uh, 7.2, you reckon? That's a backdating changes thing. Right, there we go. 7.6 in my manual. Probably a different year. Mine is from what year? '67. Mine's from 1967. Well, it shows that the circuit board's still in there. Okay. Maybe it does go with it. Alright, we'll take the screws out then. We'll go with that. So the manual I have is 10 years older than this unit. Okay, so apparently you've got to take 4 screws out of each side of this thing. I've taken the side panels off. That will then release the top panel, this top cage here, and we'll see what happens then. Apparently then it will hinge. We'll have a look inside and see what's going on. See if there's anything which looks dodgy. The main thing I want to do is look at power supplies. Obviously power supplies is always one of the things you want to look at. Right, that should now tip, apparently. Or not. Does this want to move up? I think it's screwed down as well, somehow. You sure it's just those 4 screws? Let's fold this foot back in again. There is a 5th screw, or is that the hinge? Just here. Is that it? No? No, that's different. It's not been used. Okay, well, what's stopping this moving? It doesn't want to lift still. It must be missing something else. Let's keep looking. Section 1. Yeah, okay, so we've got this diagram here. So section 1's top cover off, side covers, top metal plate, 4 screws down the sides, and number 5 is a central screw like you just said. Hey Thomas, central screw at the front. Try again. Hey, now it moves. Right. Yep, the whole assembly moves alright. Ooh. Okay, let's just do a review on this. It's hot louder. Yeah, you push those keys harder, will you? I'll take a photo of this. This is quite nice. '70s under PCB, '80s on the top side. I was looking to see if there's any identifiers on here. 8633H on that capacitor. So that could be 86. That says revision A on the board. 66511 is the board number. You've got 092486 over there. This capacitor here over here has got 8445 on it, as is that one over there. So yeah, maybe the top board is 80s. Maybe it's a replacement board. That's interesting. I can't find if I had my head in the way or not. Maybe I did. I'll do another one. So there's a screw in the middle here which I have to take out. That has now been taken out. This now moves. Look at that. These cables in here. Well, it's been done. Folds out, slotted in boards, so you've got, board edge connectors here. That's what's inside there. Interesting stuff. There's some transistors in the deal, I think. It looks at those footprints. Some TO3s. There's a meter assembly here on the back, which is screwed together from the side. I'll take the whole front panel off to get to that, which means taking these wires off here maybe, if I need to fix that meter. But yeah, very interesting construction. Nice fold out. I'll fold it back enough so it might stay up, maybe. Obviously the wire's a little bit stiff because they've been in there for a long time. There we go. And this says 0986. So although the serial number on the back of the unit says 17, which tells me 1977, the dates we're seeing in some of these things look newer. And even the board designs look a bit newer than that. So this has got 86 on there, on that cap. That may or may not be a day code, it may not be a day code. But we've got stuff on the other side, the other caps say 84. Again, may or may not be day codes, but they probably are. So that's quite interesting. But as far as the way this looks, it looks immaculate. I'm trying to see if there's any like capacitor leakage going on or anything like that. But I cannot see anything. There's a tantalum, so that might be a problem. Well, it's very unlikely to be a problem. Yeah, it looks good. Yeah, it's just nice. And I can't see anything visually which would stand out as being a problem. Yeah, spiral wrap, yeah, because it would have, in the 70s I would have used the tie wrap stuff, the threads, the wrapping with thread. 60s, 70s would have used thread wrapping. Yeah, lacing cord stuff, yeah. But it's really nice. You don't get this kind of quality much anymore. Certainly don't. So this comes back to really what is the problem. This I think is a bit wonky, which I'd be surprised if that was from original. Is that pushing? I think so. I think it's soldered. I was really surprised they were pretty wonky from factory though. That's a bit weird. Okay, well, visually it looks fine. So I might just go around and do some capacitor testing and see if I can find anything obvious with capacitors. We'll start on the top board because that's the easy one to get to. The dent on the bottom, that's a good point. Let's have a look at that. That was over in that corner, wasn't it? Trying to get it positioned right there, it's in line with that chassis there. Get a torch. It looks like it's just going to a stud on the frame. Yeah, it just goes to a stud on the frame. There's no obvious position there to go to anything attached to. It's just a mounting stuff for the frame. So why that's bent, I don't know. Yeah, the tantalums of these wet tantalums they use in these things, they're usually very good. I don't think I've ever had to replace one. The dip tantalums, yeah, sure, they fail, but the wet ones don't tend to. And the spiral caps are also very good caps, but I have seen them go bad. Let's start over here. In-circuit leaky 0.4 ohms. I'm not going to worry about the in-circuit leaky thing because it is in-circuit. It could have caused problems with reading capacitance values. 0.4 ohms, 90 microfarad. What is that thing rated at? I can't see. Well, next to it's 100s. It's probably the same. It's probably 100 as well. 98 at 0.4. Absolutely fine. Eight microfarad at 0.7. That's a 10. Don't forget, these do have like a 25% tolerance quite commonly. In circuit leaky 0.4. Main thing I'm looking at are resistances. And the tantalums, I'm sure they're absolutely fine. Let's so quick look at one of the tens. 0.3. Let's look at another one. 0.4. Yeah, that's like. I'm not really worried about the tantalums because they're going to be alright. So those ones look fine. Unsurprisingly, there is some voltage markings. There's a minus 15 volt rail there, plus 15 volt there, and I would have thought it'd be a 0 volt pin somewhere too, because these are test points. I mean, there's a good chance that's a 0 volt right there, but I would have thought it'd be a test point for it. There's a test point here. Doesn't say what it is though. Alright, well, yeah, it kind of looks okay from that perspective. I'm really careful with these wires as well, don't put too much stress on them. Let's check some more of these. Yeah, I kind of want to get this in shot if I can. Because it turns off, that's great. Well, I just tested a bunch of caps on the top board and they seem fine. Let's try and test these ones as well. I want to try and get a shot of this, but you can't really see it. I think I might just give up with it. Right. Let's try this one here. Oh, don't slip off. (101 microfarad, 0.58). That's fine. In circuit leaky, 0.52, that's fine. The in circuit leaky thing I'm not worried about, that happens. It says 1.26 on this one. Let's try testing again because this is my probing. There we go, 0.43, 90 microfarad. That's a tantalum, so that'd be fine. Can almost guarantee it'll be fine. 0.6, 97. 0.2. Oh. 0.48. Usually we get a misconnection, it's just gives an error. 0.45. They are looking fine. I mean, this one here is a tantalum. Let's just quickly look at it anyway. I expect it's got nothing wrong with it though. .3, yeah. It's like every cap is fine. Also, you've got these big caps here, which can be pains to get onto. Got these marks trying to read them. Uh, 450 microfarad, 50 volt. And the same, both the same. 617 at 0.1. Getting a little dodgy connection there. So again, because they're slipping. 480 at 0.1 again, or 0.17. So they're fine too. Caps that good. Or the caps that good, I should say. Right. So I don't think there's any problem with those. At least not the ones I can get to. Now, we have an issue with the meter still, with it sticking. Whether that's part of the problem, I don't know. But we were getting those fact that it wasn't really reading, and it could just be dirty switches. I mean, the switches could need to get cleaned. It's entirely possible that it could just be bad switches, and they need to go clean up, because mechanical stuff often has issues. This kind of age, anyway. So it's likely what's going to be wrong. So I think I need to try and get to the back of these switches and put some deoxit in there and try and clean those up. And there's another little cover here, which I think I can remove. I think I can take that off. I think it's got 2 screws, so I'll take the cover off. Let me show you that. So just in here. So I think take those 2 screws out, I think the cover will come off. It appears that way, and I think then I can get to those switches and try and get some deoxit in them and give them a clean up. And that may be part of the problem. Again, I've got to think about how I get this meter out, because that's something I'm probably going to need to look at as well. It may free up with usage, but I doubt it. These fit tantalums with 25-year service life, yeah. Much more fun when you reverse bias them. Yes, don't do that. Oh, I should have passed by first. Well, yeah, I mean, I don't necessarily always check power supply. I should. But I tend to just look at whether the caps are bad or not and go from there. I always assume capacitors are bad unless I've got a reason to not suspect them. And a high quality piece of gear like this, you know, they're not so likely. But obviously the age is a problem with these. Then, you know, there's no signs of leakage. They all look perfectly fine. So I'm not worried about these caps at all. They measure alright, they look good. There's no signs of any dirt or anything inside. This thing looks immaculate. So anyway, let's see if we get to these switches. I'm thinking that's probably a mechanical problem. It could all be mechanical problems. It could be the switches are bad and the meter are bad, being mechanical issues. So let's pull this off. See if it'll give me access to the switches. Yep, there's the switches. And they're open frame switches as well, which is brilliant. So I've taken the cover off, and there's the switches underneath. And as you can see, they're actually open constructions. It's like a PCB with the contacts being pushed through them. So these are all completely accessible. You can see the contacts are moving backwards and forwards. So in a way that's good, because it means that it's easy to get into to clean it, because I can get the contact spray straight in there. Also in a way it's bad, because any dirt and stuff can equally get in there, but the inside of this thing's pristine, so dirt isn't really going to be an issue. Maybe oxidization will be an issue. So I'm going to put some contact cleaner in this stuff with the deoxit stuff. I'll put it through all those switches, and you know, it's going to need it. But hopefully it helps things a little bit. got the supply rails, yeah, we'll do. I'll do something with it. I'll probably chuck a multimeter on it and see if it ripples with that. It's probably good enough. It's usually good enough. But I'll clean these switches up first. So the inside looks good and there's no obvious damages or anything like that. So apart from that one little bit of chassis which is looking slightly bent for some reason, which is interesting. But otherwise, all right. Let's get some deoxit. Should use the standard stuff. I should have used the gold. I think I used the gold one. It could be gold contacts. Zoom out again. I'll use this one. Let's try and spray some into all of these contacts. Because this may be part of the problem, is that it's just big of oxidation inside these switches because it can get to it. Right. That's that spray in there. Let's work them a little bit. Indeed, Thomas, I'll tell the guy to type pretty loudly so you don't miss the catch fire thing. Actually, even that feels slightly different. That's actually changed the feel of switches. Thrilling, isn't it? How do you stand the excitement? Did I miss one? So we've got this calibrate zero adjustment in here, which is a pot. I might spray some pot cleaner in the back of that because there's only the zero adjustment. Just want to make sure there's no debris in there. Bit of fader. Right. There could also be some of these problems are with the adjustments, right? Because it's got those little trimmers on the top. Those plastic ones are usually pretty good. They don't tend to go bad because they are fairly well sealed. But you've got this open one down the side on the chassis here as well, which is adjustment, calibration adjustment. And there's probably some other stuff around which may or may not need it. I mean, these ones may need it, but I don't want to touch anything, right? I don't want to touch any of these calibrations because right now they should be right. It just isn't working. So, yeah. I'm hoping it's a switch problem or something like that. So that one that's on the side here, I don't know what that's marked. It doesn't say what it is. Over here it says calibration output, which would be going to pot on the top PCB here. Yeah. So it goes to this pot here. So that's the calibration output, is this pot here. So again, reasons to not touch stuff. So I'm just going to go with assuming that the issue is a dirty switch. So I'm going to put this back down, and we shall power it up. Obviously we have to figure out what to do with the meter. If we can get the thing to work and it is functional, then the meter will be the next thing we do. It's got the meter movement sticking, is it? Now, there is deoxit in these. Maybe they'll spark and catch fire. Could we get some excitement? I don't know, I doubt it, but yeah. Turn the power back on. That is off state. Put it onto 1 volt. Meter moved. Shut that back in there. I think I might take this off. Calibrate. Ah, this is different. 1 volt. Calibration. Something is different. Something has changed. That's always a good sign. Calibrate. Look at that. It's no use here, yes. Alright. I should be recording a video. So, powered it up. Turned it on. Put a 1 volt range. Push the power button. We're getting 1 volt. So that is actually working now. Before we didn't have that. Zeroing is working. I'll try and get it about 0 for me. Maybe not for you. About there somewhere. Slightly less. Calibrate. And that's just over 1. So that is now different. That's working. Before that wouldn't do that. So either me moving things around has solved the problem, or me cleaning the switches has solved the problem, because I cleaned all the switches. So that's looking promising. Let's try injecting some signal into this thing and see if it registers it. So I'm still injecting 1 volt RMS. At 10 kilohertz. But we're getting that. And now it's gone, and it's come back. Dodgy connections. Okay, let's try something else. Let's stick this. That is not a negative probe though. Let's just shove it on there. We'll stick this on here. Yeah, different dodgy connections on somewhere. But where is it? Is it in the cable? Is it on the head? I think it's in the head. So we do 1 volt RMS, and we are actually getting 1 volt on a scale. Now we've got it to do stable readings. Let's change this level. Let's do 100 millivolts. Actually do 300 millivolts. We're up there. It's not accurate, but it's there. I don't think I'm using a signal generator for this. And that didn't change. I don't need to do something with this. But that's still saying the same thing. It's staying full scale the whole time. And it's still saying full scale. Well, that's not the same. It was working. Right. Getting there, but why did it do that? That's curious. Okay, let's come back. No, there's something going on there. That looks like a leaky transistor or something. Potentially. The meter has stopped sticking now. Yeah. Is that going to have to pull that apart now? But this isn't right. Okay. Well, let's check power supplies and see what's going on there. It could be ripple causing problems. It's still possible. Menu. I've got AC and DC. AC and DC. DC and AC. Right. Let's see what we get. No, let's check for any ripple on the supply. I think I'm going to be there as negative, potentially. This is marked as minus 15 volt rail. I should definitely turn it on first. No apparent ripple, at least nothing in the millivolt range. And you're getting 14.97, that's fine. And the other one over here, which is marked as plus 15. 15.024, and no apparent ripple. Well, those look good. Let's do millivolts AC, and just look more closely. Yeah, about 4 millivolts on the minus rail, and about 2.5 millivolts on the positive rail. That seems fine. Does the manual have a spec in there about what the maximum ripple should be? Just in case it does want better than that. Now it does have plug-in boards, alright, so I might actually need to try and unplug the boards and plug them back in again to reseat them. Clean up the gold connections. Okay. See if I can find information about the power supply. I expect it is in here somewhere. Interesting, goes straight into the range information. The probe assembly. Would have thought we would have started before that. Power supply adjustment. There can be plus or minus 200 millivolts on us power supply rails, so those are fine. Doesn't mention ripple. Interesting, doesn't mention ripple. Yeah. Okay, well, it didn't mention ripple in the power supply section, only about adjustment voltages, that was it. Interesting. I guess I don't really care about it. Page 514, 150 millivolts, well, we're way below that. 514. Oh yeah, there we go. Yeah, power supply ripple check. Well done. Measures oscilloscope measurement. Yes. Well, I'm sure this is good enough. Normal line voltage and pulses. Yeah, normal line voltage, yeah, okay. Well, yeah, okay, well, that's looking fine, at least on that board. So I think I'm going to need to sit down and actually study this manual and just go through a diagnostics procedure and work out basically where to start and what's going on. So what I might do though is actually reseat the circuit board. No DSO. Yeah, well, I could, but I'm being lazy. So what I think I'm going to do, a common thing I find in older test gear, even if it's gold contacts like this has got gold everywhere, is to actually reseat the board. So take the board out, put a bit of dioxide on it, maybe even scuff up the circuit board edges a little bit with a bit of fiberglass pen, just really gently, or even a paper towel will do it sometimes if it's not too bad. And just clean up the oxidization on the gold. I mean, yes, true gold doesn't oxidize, but this isn't pure gold, right? So you're going to get some oxidization. So something I've done many times in the past, which is even completely fixed test equipment, is to clean up the board edge connectors and reseat everything and clean them all, and sometimes that will fix a problem. So I'm going to do that on these boards. I'm going to clean up these board edge connectors and see if it does anything to improve the situation. It may help, it may do absolutely nothing. But by giving it a clean, well, we haven't lost anything, have we? There's also a plug-in connector for the probe inside the box. Now, because this is a gold-plated board, and it may matter about touching it, what I'm going to do is put some gloves on. Will I completely repair this year? Oh, that's a challenge. So I was a recording video when I said all that stuff about the board edge connectors. You guys need to tell me, otherwise I might have to say it all again. Page 708 shows the probe connector. Okay. So I've got some gloves on because I need to take this board out to clean these edge connectors. I don't want to contaminate the board with my greasy fingers, so hopefully I can lift this up a little bit and actually get it out. Hopefully. It's moving. Lift this up. Okay. There's the board. And there is a little bit of tarnishing on there, but it's not much. And there's the back of the board. All very nice. But like I said, I'm going to give this a clean anyway. I shall refit it after that. Deoxit gold, and I am going to hit this with some paper towel. Like I said, I don't think it looks that bad. I think it just needs a little bit. Yeah, that's doing a good enough job. Right. Now when the corrosion or oxidization is quite bad, I'll actually use the fiberglass pen instead. But obviously it's risk of actually taking the entire plating off, so I don't like to use that unless I really need to. And a paper towel is usually abrasive enough. Okay, so now I'm going to put some pressed geoxit on here and push it into the socket. There's definitely some oxidization on that bald edge. There's probably some inside the actual connectors as well. I'm going to have to plug this in a few times to get those kind of scraped as well. Recording video, shouldn't I? So I've cleaned up the bald edge connector with some paper towel and a bit of deoxit. I'm just going to seat it back in again. Hopefully, it's a bit tight. Hopefully I can get it back in. So I'm going to basically push it in a few times and pull it back out again, just to give it a bit of a scrape. But it's actually having trouble getting back in. I'm having trouble getting that back in again. Very tight, doesn't want to go in. That's what she said, isn't it? Come on, wriggle in there. Wow, that's really struggling to push back into place. Not liking that at all. I'll push on the back of that to hold it in. That's better. It's pushing the PCB out the way at the back. Get back in. This is surprisingly hard to get back in. Yeah, I'm really surprised with how tight those connectors are. Anyway, it's back in. That was a bit of a challenge. Let's put the screws back in and I'll do the other board. Is it now time for the DVD player? Well, it could have been. Could have spent ages working on DVD player instead. That one there is just hopefully a simple issue, that DVD player thing. It's an audio problem. Basically it doesn't have any audio, so I think it's just a bad connector problem. Like a audio socket from the headphone jack on it. That's what I think it is anyway. Alright, set that one back in. Do the same for the other one. And of course it's got these adjustments on there. I want to be a bit more careful with this one, because I'll knock those because they are exposed. Let's record some video on this, I suppose. So I've done the top board now, that one's back in place. Certainly was a challenge getting it in there. Now I'm going to do this board, do exactly the same thing, take this one out, clean the connections up, and see how that goes. So the other one was really hard to get back in. I was quite surprised how tricky that was. This one I expect to be the same problem, but I've got to be careful when I'm manhandling this board because it's got the adjustments down the sides. And if I knock those I could actually turn them, so I've got to be careful about that. Okay, that's out. And yeah, there was a little bit of tarnishing on there. Barely, just a little bit. So I'll do the same with this as well, give it a clean up, put it back in. White, silver and gold indeed. Like I said, there's been plenty of times when I've done this, cleaning up the ball dish connectors, and it's fixed problems. The HP Fluke, was it 5.2 something? I can't remember what it is now. Done it on that fixed that. The Marconi 2955, a lot of that problem was just dirty edge connectors. You know, so doing this does make a difference. Don't actually know if you can see it on camera or not. Probably can't. No, it doesn't really show up too much. No, it doesn't really show, but I can see that there's actually a difference in surface. You can kind of see it there on those traces there. We've been rubbing here. See that difference? So there is a definite difference in texture there. So yes, it's doing something. Yeah, the old HP stuff was designed to keep on working. It is designed to be high quality, no corners cut, and you know, the best you can buy, I think that's basically what he was based on. And a little bit wrong. yeah, these days it's a case of build it so it'll last 2 years and then fail. That's what most technologies like these days. And I think that's why there's been, well, my manufacturers were so keen to adopt lead-free solder, because they knew it wasn't as good as leaded solder. I mean, obviously there's environmental aspects and what have you, but it was in the manufacturer's interest to have their products not last as long. And if I can say it's not from manufacturing defect, because I don't know, ineffective solder is not really a defect, is it? It's designed that way. It's intentionally made that way, so it's not really a defect. But yeah, you know, that's why things failing these days, because a lot of times it's bad solder joints because of this solder is lead free. I mean, sure, the quality is getting better these days, I think, but I think there's been improvements. But and yeah, getting lead out of the environment and that stuff, I don't really have a problem with that at all. But yeah, I think manufacturers really jumped on that whole thing, like the whole same thing with electric vehicles. You know, the whole jumping on lithium batteries. Well, yes, lithium is great, but it has a finite life, and manufacturers know this, so they know that your car's going to last you 5 years, maybe, you know, 10 if you're extremely lucky, and then you have to get a new one because your battery's knackered and it's too expensive to get a battery compared to buying another car. You know, getting a car's the same price as getting a battery, so why would you bother getting a battery? You just go and buy another car. There's money in it for them. Whereas other technologies such as hydrogen, for example, which I know very little about, but you know, a little bit, I think it's better. You know, I think there's better options with, you know, perceived safety risks, I suppose. Anyway, got too much on there. Get some of that off. This is my opinion. I mean, I could be completely wrong. Could be talking a whole bunch of shit. I don't know. But yes, it's my opinion on things. Anyway, if we're lucky, cleaning these connectors up will fix some problems. So I also have to look at that probe thing, wasn't it? It's section 8, something? 8? 5, was it? Okay. Let's back in. Probably in gloves, I can't grab all of the screws to put them in. Shaft and mains filters, yes. Yeah, that's because I think they've got reefer caps in them, and that's not design obsolescence. That's purely a limitation in physics because they've got a plastic casing on them, and all plastics shrink. All plastics shrink. So the plastic housing on them shrinks, it cracks, then it lets moisture in, and then the capacitor is no longer a capacitor at a certain voltage level. And it also creates arcing, and then bang, off it goes. So it's purely because the plastic cracks. That's what causes those to fail. If the plastic didn't crack because of shrinkage, you'd be right. If they actually maybe put a larger package around them with more epoxy instead, rather than the plastic case, then they probably wouldn't have never failed at all. Alright, that's that bit. So how do I get to this probe thing? It is down there. Yeah, how do I get to that? When we're driving on a tank of hydrogen, well, where is that aspect, I suppose? So, should we try it out now without doing anything else? I think we should. That's off. We should recheck this. I mean, I think this bit here has also got a bit of corrosion on it as well, eh? This tip. Right. Did he have it there? Right. Right, let's try this again. Power is off. Turn the power on. 1 volt. Calibrate. Oh no, it's still doing that. So the thing we had to do last time, where it goes high scale, is still doing that. What's going on there? So it was working properly before, and then it started doing this. So is there an issue with the cabling, maybe? Don't know. Something's going on. Well, we went from it almost working to being faulty, so yeah. But cleaning the balls didn't fix this problem, which is a shame. It would have been nice if it did that, but something else is going on. Thanks for dropping by, Dave. Catch you later. So, what's going on with this thing? Why is this suddenly doing full scale? So let's look at this manual here for what was mentioned about the probe. Probe filter. Probe connector. There we go. Right there. So it looks like I've got to take the bottom casing off. Yeah, okay. Well, at least the meter's working here, but it stopped sticking now. That's something. Let's take a guess for these screws and see how we go. Oh, it's not quite there yet. What else screws we'll take out? Those ones there, those 4. These 4 here have to come out. Still no. Let's keep going. Is that in the way? No, I think it is actually. That's right. Just take them all out. What could go wrong? That one didn't have a lock washer on it. All the others did. Right. Two more screws and a cover. So I've taken the bottom cover off, I took all the screws out to get it apart. I've still got this cover here, which I'm going to undo as well. And that should give me access to the connector for the probe, I believe. Kind of, if I can get it to lift up. There we go. Right, there we are. Probe connector. So I'm going to unplug that and reseat this as well. And check this out for any problems. Yeah, some tarnish on there as well, so this needs cleaning. We shall do that. Now I might take this screw off here so I can lift it up more. This is using the same screws throughout. Cool, that's better. So I'll clean both sides of that. And we'll see if that helps. Your 3400 seemed complicated to assemble. That wasn't that bad. 3400 wasn't too bad. On the surface it looks complicated, but it's actually quite easy. Right. Put some more cleaner on this. I can actually still see tarnishing on there. I'm tempted to hit that one with a fiberglass brush. See how this goes first with a bit of reseating. Come on, here we go. Right. This one's not easy to get in and out. You don't feel so bad now. The four loose spaces you need to access the batteries. Well, it's not like you have to access the batteries very often, though, is it? You know, once you've assembled it, it's pretty much it, doesn't it? Right. Let's put this bit back together. Now, should we try it as is? In case I need to do some measurements from here to the probe or something, I don't know. Don't know if it's something I need to do or not. Power is on. 1 volt. And it went shooting up again. Yep, something's definitely failed, I think. I reckon something was on the verge of failing before and it's now gone because we can't get rid of that. Yes, the video is upside down. Just retesting it again and cleaned up all the connections and it's still bad. I think I need to sit down with the manual and actually try and do a proper diagnostics process on this and try and figure out what could be causing that meter to deflect like that. I think something somewhere has failed since I started working on it, which is a shame. Could be a bad connection, it could be a broken wire, could be something as simple as that. But yeah, I don't know. Had to figure it out. Well, yes, I did consider that, which goes into here, and the issue is that I'm seeing is obviously the meter's deflecting when it shouldn't be deflecting. Right, so I mean, yes, I could certainly clean that, but something else is going on here, which is annoying. The probe lead could be shorted inside. It could be a faulty probe. It certainly could be. Yeah, I imagine this can be dismantled somehow. I think that's a small screw just there. So I think the probe can actually be dismantled. There's two screws, I think, there and there, which lock it together. So this was working okay until I'd used this lead to clip it to my generator. That was interesting. That it was okay until I used this. Why was it okay until I used that? Also, this bit screws on. Probably just coincidence. So I don't know. Could easily be a bad cable. So I need to consider my options here. What do I do with this? Well, what does the manual say about the probe? Section 8, wasn't it? That's the probe socket I'm looking at there, not the probe itself. So it shows how to get the socket apart. But I don't think that's where the problem is. See, if I'd actually looked at the manual beforehand in any detail, then I would actually end up better understanding what's going on here. So here's a sampling probe. So pulse in, meter hold, FET source, so it's using FETs, FET source, FET set drain, positive, negative, and feedback. That's what's going through there. So these are feeding a FET. It's possible the FETs fail. It's got a fit current source there. Don't know, it's going to require some further investigation, I think. So I think there's probably a FET in the probe itself. Hopefully that's mentioned in there somewhere. I expect it will be. I expect it'll be in here somewhere. Yeah, there's lots of approaches I can use to this. I'll just have to try and decide which one would be the most appropriate. If it's a probing problem, I mean, the thing is, when you've got cables like this and switches, those are the things which are going to go most likely, because mechanical, physical things, they're the things which usually get the damage, right? From, being pulled on or dropped or whatever it may be. So it looks like it's got an amplifier and a probe head from that. So I think I need to look at this and figure this bit out in detail. So if I unplug the probe head, right, so there was no probe connection, that's now not plugged in. That will eliminate the probe if it still does it, potentially, unless it's just floating voltages, of course. Still does it. So let's see if there's any floating stuff. Maybe I'll be touching it will change it. No. So it looks like it probably isn't the probe, because we've eliminated that. So I shall do a video on that bit. So now I'm trying to narrow down why this needle was moving. Is it the probe? Is it a fault with the amplifiers built into the probe? I've already got a certainty that the connections themselves are okay. So what I've done now is I've unplugged the probe and I'll turn it on, and you will see, because I demonstrated it just now, that the needle is still doing the same function. Works exactly the same way, comes up, all right? And touching around here isn't creating any loading effects or anything like that. Obviously I've got gloves on, but it should still have a effect if it is a loading problem. Where it's just floating voltages, so it's not that. So I think I've eliminated the probe as the problem. I think it's something else in the circuitry, in the amplifier chain or something like that, or a leaky transistor or something like that is dodgy now. Oh, at least it's not the probe. Well, it seems not to be the probe anyway, so we can eliminate that bit and move on. Zeroing procedure, yeah, I don't know. I did see you mention it, Dave. Where is it, David? Where did you say that was? 3.1, okay. I think I'll put this cover back together again. I don't think it's in here. That way around. Okay, you better hobbyist. Catch you later, mate. Thanks for dropping by. Come on. Drop the screw. Damn gloves. I'll probably take them off again now, but not sure. Right. Let's look at the meter. Yeah, it's not too hard to get front panel off. It's alright. Okay. So, section 3.1. Well, the zeroing is just that knob on the front. Which I've already tried twiddling with. Obviously it does cover the calibration using the cal adjustment there, which I'm not going to change yet. Yeah. It mentions using the isolator tip, which is a tip I don't have. Yeah. Most of these screws are the same. There's only a couple which are slightly different. I think this one's a bit bigger than these ones. It's alright. Okay. Power is still on. I should make sure I turn it off before I stick my fingers in there and do something silly. Just having a little look around. I mean, maybe with me lifting the cover up it's broken a wire. It's possible, because it was working better than that before. It all seems to be quite well secured. I'd be surprised if that's a problem. They've got little loops on them and everything like that, so there's no actual strain on the wires. It's got a strain relief mounting there, actually secured on. So no, I'm not seeing anything there which looks like it's potentially damaged or stressed. The other ends are all nicely looped and they're all secured nicely too, so it's not that end. Yeah, I can't see anything here which would be giving trouble. We'll check solder joints on the back of this board here. We'll check those. In case something's gone wrong with them. You're wiggling things around. As possible. Can't see anything there, at least not like this. Yeah. Yeah, well, it wouldn't zero that with the cow button out. I did try that before. Wasn't doing it. Yeah, that forced scaling. That wasn't happening before. So, obviously, as I've used it more and more, it's failed in some way, or a fault has become apparent. Something like that, anyway. So, it was working properly with the cow button before, in and out. But sometimes it did actually come up and stay up. Did do it a couple of times before. So, yeah, I don't know. Yeah, might require some more investigation here. I mean, is this a relay? Or is that just an inductor? It's just some kind of relay. That's a relay here. That's a relay there. Maybe it was sticking before, yes, and that stopped happening. So that was a good thing. Yeah, definitely got a relay just here, which you can't see because I'm out of shot. There we go. Right there. There's a relay there. I think that was also maybe a relay too, I'm not sure. Yeah, I can't see anything where the wires have been stretched or damaged by me moving this around. They all seem fine. So, turn this on again. Put it back on there. I'm going to try moving some things around. No. Use the wires. Move these ones this side. No. So that's not changing anything. So I don't think it's a connection problem. Curious. So that relay seemed to be from the probe. We've got that button on there. So I'll fold this up again so I can see it actually moving. No, that's that one over there. That's that relay there which is going. Yeah, definitely over there, I think. No, it's just sound travelling. So it is that one there going. So that is operating, and it seems to be irrelevant to what's going on here. Zeros turn right down. I think I'm going to have to go through this in a logical manner and just trace through the circuitry and just try and narrow it down in a way which shows me where things aren't quite working right, because there are a bunch of like scope probe things here going on, so I can go through these and do a logical process through the circuit. But to do that I need to sit down and read this manual, read the theory of operation. That'll get me a lot closer to where I am right now, which is something doesn't go. And we've done all the basic stuff, which is good connections, good switches, and verified that things are not broken. So yeah, it is nice for me to stop sticking though. The meter did go full scale when I did the lower range. When I came down here, so when I was doing like the 1 volt, it's only come up like around here somewhere, wasn't it? But when I did the 0.01, this is before cleaning the switches, then it was actually coming up. So the meter will move that far, and it was actually doing that range. But once I cleaned the switches, then that changed that. Yeah, so yeah, I think I'm going to have to do some logical testing on this thing. And what now? I'm just sort of, I don't know enough about it yet. I need to sit down and study this. So yes, not quite the outcome I wanted for today. At least we fixed one thing. We fixed the remote control, and that was quite interesting. Now demonstrating that issue with that. Glue has gone off now, thankfully. So we can put the battery back in. Get away. Hopefully the switches are in the same place. I think they are. Come on, get back in. Okay. Right. Okay. So I think what I'll do is I'll reassemble it so I don't forget where the screws go. And I'll go away and study this manual and figure out what to do next with it and work out a plan of attack. Because right now I don't have one and it's messy. Yeah, it's after cleaning switches. So it could have been the switches were hiding a fault. Like I said, when I was only getting a full scale, I went down to this one here, the 0.01 is when I got full scale out of it. Before then, I never got full scale. So I'm thinking that the switches being a problem were hiding the fault was present, and so now the switches are working correctly. The fault is now shown up. So it could have been there the whole time. It was there. But if there's a ratio problem with this divider from these switches, that could be a clue. Because I'm sure these are going through a divider system. Deoxide switches, well, maybe too much in there, but I can run some IPA through it and flush it back out. Let's just try and find those switches. I did see them here. Here we go. Here's the switches here with dividers. So these are 400 ohm or so. The smallest resistor there is a 30 ohms. So leakage from the switches, not likely, not those resistances. If it is, 1 or 2 ohms, then maybe. But if you're going across the full range and it's not changing it, I don't know. Could still be something related to that, but anyway, I need to sit down and study this, figure this out. Supposed to be a joke. Well, I mean, the thing is though, when you got gear which is sensitive to leakage, leaving residues behind from cleaners can cause problems, right? So it is actually a valid thing to say. Too much deoxit could cause a problem. That is actually a valid statement. So that's why I actually entertained the thought for a minute there and just went and had a look in case that could have potentially been causing it. It still may have an influence, but I don't think that is the case in this situation. I think all we've had is a fault which has been there the whole time, and the switches being dirty hid the fact the fault was there. Yeah. Or we just got unlucky and something failed whilst we were doing the testing. When I had that probe on here, we were measuring voltages on it. It was actually measuring a voltage. It was working. Right? So we had it on the 1 volt. We did read 1 volt. Okay, we're getting it. And then it failed. So is it because I was injecting a 1 volt RMS signal? Unlikely. And it's supposed to be able to take 30 volts peak to peak, so it's not like we're exceeding the ranging of this thing. It could handle it just fine. Yeah, I don't know. Could it have been something else? Could it have actually been, maybe when I was injecting that 1 volt, maybe it wasn't actually measuring at 1 volt. Maybe that's when that fault showed up. Maybe because it is doing full scale, right? So maybe we thought we were measuring 1 volt from the generator, we weren't actually measuring it. What we're seeing is the fault. Possibly, because that's that time when it showed up. Yeah. Okay. I think I need to leave this and put it to one side. And study the manual, like I said several times now. I need to get my head around it, understand exactly how it works, and figure out a troubleshooting process, and basically know where to start, which is probably going to be on the amplifier chain, most likely, starting from the input amplifier, where this probe goes to, and tracking through the amplifier stages, and figuring out that part. Yeah. But nice if it was on the top board. I don't think it will be. Anyway, okay. Let's kill that. And I'm going to put this thing back together. To a point. I might... Yeah, I think I might put the bottom cover back on. I don't think I need to do anything under there anymore. Let's turn the power back off. So this is one of those horrible filters which can blow up. Watch out for those. When they go, they make a huge mess and terrible stink. So we've got a 2N3054 and a 2N3740 down here. Plug-in. I think they're plug-in. Yeah, they've got sockets on them, so I can always unplug those and test them if I need to. In fact, yeah, I think I will leave the bottom cover off for the time being. Just looking at this, is looking a bit glossy. I think it's just, yeah, it's not wet or anything. It's just the coating they put on the transformer. The name's gone out of my head now. Okay. Should I try reseating those? I don't know. Anyway. I've got the rest of the day to play with this, so I will do that. I am not going to be doing any more work on the bus today because the weather's not destined to be good. Tomorrow is supposed to be better. I think, yeah, tomorrow for the next 4 days is supposed to be good weather. So there's a good chance that I'll end up working on the bus and doing those other 4 windows over the next 4 days. So today is my chance to get this thing figured out. So yeah, so at least you'll get to see some different video when I do release the video on this thing, when I get it fixed, if I get it fixed. How many sections the video will be in, how many parts, don't know. But the circuitry looks relatively straightforward, there's not much to it. So I should be able to sit there and diagnose it. I mean, yeah, it's a shame the transistors aren't on sockets, because you can unplug a transistor, plug it back in again. Some gears got transistors which are on sockets. That's really handy because your dodgy connections, just unplug them, plug them back in, or swap them around if you need to, diagnose things. Thermal camera, yes, possible, but I don't have one. Rubber gloves are on, yes. Hey Christian, yes. Rubber gloves are on, so we did mean business. Because I didn't want to put my oily residue on these circuit boards in case it mattered. It may not even matter on these, but I don't want to risk it. Pass transistors for the power supply, probably not a problem. Yeah, well, we measured the fine on those, didn't they? They measured okay, so not likely to be those. So, yep, I need a logical approach. So I think I need to cease where I'm at and tidy up and get some space back on this desk and go start in a manual, like I said, several times now. Let's put this away. Let's take his gloves off, it's getting in the way now. Okay, so I was actually thinking about doing extra live streams because it is the Christmas holiday and I'm not at work for another 2 weeks. So I was thinking I might do like a midweek live stream or something like that. What do you guys think about that? Would that be something you'd be able to turn up to, or unless you're, you know, if you're still at work or whatever, maybe you can't do it. But so I'm considering doing it maybe a midweek live stream. Probably wouldn't be this week. This is in an evening. Maybe I could do it in an evening. Possibly. I'm only trying to do like one window a day on the bus because physically it's a bit hard because you've got to get all this sticky stuff and your fingers get sore. And I actually injured my knuckle on this side or something. There may be a tendon. Because the stuff's so sticky and I was trying to pull my fingers apart and it hurt just in here. And it's still not quite right yet. So yeah, so I'm lucky to do one window a day. And less likely to do two. Not likely at all. Yeah, so I'm thinking about doing a midweek live stream or something at some point, or some other live stream. Maybe it's a consideration. So watch out for those popping up. Guate, is that? Guate Q, Happy New Year. Yep, thank you. You too. Yeah, sitting down to dinner. Okay, no worries. Right, well, I'm going to wrap this up then, and I'll go over some lunch, and I shall sit down and start studying the manual. So thanks everyone for dropping by. Don't forget to give us a thumbs up before you leave. And I may or may not do another live stream. We'll see how we go. It won't be today, I don't think. But yeah, just watch out for it. I might do an extra one, seeing as I'm off from work. And if I get bored, I might do a live stream and look at something else. Maybe I'll do the DVD player instead. And just leave this tantalisingly sitting on the side of the desk, unfixed. Okay, catch you later. Thanks everyone for dropping by.